Hello everyone. This will be the lab session for the word embedding lecture covered by Professor Suman Mitra. I think still participants are joining. Should we wait for some time? Hello, am I audible? Can
Yes,
someone
sir, you
respond?
are audible.
Okay,
Yes.
okay, great. Okay, fine. So I will go ahead and start. I think the participant can watch the earlier sessions if they want later on YouTube as well. So what we'll be discussing in this lab session is how to train the word embeddings like word-to-vec and fast text. The theory lecture of this has been covered by Professor Suman Mitra. For the conceptual understanding, we can maybe again go back to those lectures and see it on YouTube as well again. So the first fundamental thing which is required for training this word embeddings is a text corpus. So higher the text corpus, the better it is to train. So the final word embeddings which we will get will have a better representation. So in this example, for example, if you can see the screen here, I'm downloading a text corpus. So this is a standard text corpus, which is a small text corpus, kind of a toy data set, which is usually used to train word embeddings for the English language. It approximately the size of the data is around 100 MB. So this is a zip file which has been downloaded and extracted. So I will start with word-to-vec. So for your information, the original research paper also I have shared here, and this collab notebook I will share just after this session. So you can also take a look at it, and it will be also helpful for you in the assignment which I'll be talking about at the end of the session. So what are some of the important parameters of word-to-vec? So the first of all is the dimension. So the default dimension is 100, and the dimension means when we are converting a word into a vector. So what will be the dimension or the length of this vector? So usually the default one which is present is 100, and it describes the length of the dense vector, which is used to represent each token or the word. The next important parameter is typical sizes are like 5, 10, 15, 20, and the default is 5. The next important is the mean count. So what usually will happen is it is important that a word repeats quite a number of times in the text corpus so that we are able to get some good representation. For example, if it is just present one or two times, the context words might not be enough to learn a good representation. So usually we put a cap on the minimum frequency for a word so that we use that word in the training and generating the word embeddings. For example, when you set it to 5, and let's say that we have a word which has frequency 1 to anything less than 5, so that word will be discarded. It will not be used in training the word embeddings, and we will not have a word embedding vector for that particular word. Workers is simply the number of threads which we will use. So generally what will happen is the entire corpus will be divided into chunks based on the number of threads, based on number of threads or workers. Let's say if we have 3, so the entire corpus is divided into 3 parts, and parallelly these threads will try to run and train the embeddings. Next, very important parameter is this SG, which determines whether we are using the skipgram algorithm or the CBAV algorithm. So as you already know, in CBAV algorithm, based on the context words, we will try to predict the target word. And in skipgram, it will be the opposite. Based on the target word, we try to predict the surrounding context words, and the number of surrounding context words depends on this window. If the window size is, let's say, 2, so the 2 words on the either side of the target word. If it is 5, then 5 words. Similarly, it will keep on going. So here I have also provided some few links for you to refer. And a very good website here is this website which I've shared. Let me try to show you a basic thing. This is a word embedding visual inspector. So you can do some configurations here, and you can also try to provide the context and the target. And based on that, you can try to do some changes here and try to see how the vectors are generated, how the weight matrices are generated. So I suggest you that you play around with this website. So it will help you in a better understanding. Yeah, so let me come to the training of the word to vec. So the library which we'll be using is Gensim. In Google Colab, it is available out of the box. You do not have to install. Otherwise, if you are using a Jupyter notebook, your local environment, then you have to you might have to install this library. So you can use this command to install Gensim. And one more suggestion I have is particularly if you are trying to train a very large corpus, let's say you have 500 MB, 1 GB, 10 GB. Typically for applications or for research, large corpuses are used so that you get substantially good results. So in that case, I suggest you to use the original C code because it is much faster than using this library. So I have provided the GitHub link. You can clone this repository, and then there is a shell script which you can use to train the word embeddings. So in this particular lab session, I will be telling you about this library Gensim and how you can train using this library. So I already had told you about the text corpus in the initial, which we downloaded. The name of the text corpus is text8. So we will read this corpus. So the general expectation is that every line will have one document, and we are reading all the documents from this particular corpus. So you need to make sure that there is one line on each document. So the thought process behind is one document will have some related, so there will be some relation between all the text which is present in that one document. And next thing is doing some sort of pre-processing. So this is the default pre-processing code which is provided by Gensim library. So you can also refer to the Gensim library as well. This is the link uh, which you can use. So it has the documentation as well. So what this code will do is it will read the documents line by line, and it will pre-process, essentially remove the punctuations, non-alphabetical characters, make the text lowercase, and it will make so every document will be a list of uh, tokens. So each token is a word, so it will become a list of tokens. So the input data which we need to provide to the Gensim word to vec training has to be processed in this particular way, and this code is doing that for us. So the next thing is, from this particular corpus, we are generating all the sentences. So I am using sentences and documents synonymously here. And the next thing which you do is you call this method Gensim models.word2vec. You pass all the sentences which we have got by pre-processing, as I mentioned earlier. So then you specify the parameters. For example, I have set skipgram is equal to 1. That means I'm going to use the skipgram algorithm. Window size is set to 10. Dimension of the vector, that is the vector size, is set to 100. Minimum count is 5. The number of threads or workers is 16. The number of iterations. So this number of iterations is quite important. Based on the number of iterations you specify, it will also decide how much time it is going to train this model. Also, the quality of the word embeddings which will be generated. So yeah, so I will not run this here because it usually typically takes quite a lot of time. It might take some 15 to 20 minutes. So I will share this notebook later to you. Maybe you can play around with it later. Yeah. So I have already trained this, and this result I have printed it out here. So this tells me how many number of words in total are present in the vocabulary. So around 70,000 words are present here after training the corpus. After training the corpus using word to vec, and you can get a vector for a particular word using this particular method, get vector. You pass the word. You always make sure that you take care of the case. For example, since you have lowercase in the pre-processing part, so you always have to pass the lowercase word. Otherwise, it will give you an error that word is not present. So for example, in this method, most similar for the word king, it is printing out the top two most similar words. I think in your initial lectures, sir had covered cosine similarity. So based on cosine similarity, uh, the similarity of the vector of king is computed with all the words in the vocabulary, and the top two most similar are printed it out here. And you can see that it is giving very similar and related words like ruler and chief, and the value of the similarity is also printed here. So this particular word to vec model was trained on the small 100 MB corpus, a toy dataset kind of thing. And Google actually has released a model which has been trained on a large corpus, Google News corpus, and it is able to encode the word vectors much better rather than the small corpus which I have presented here. So if you'd like to work with this, I have provided this code for you here. So what it will do is it will automatically download the word to vec embedding which was released by Google. So the dimension of the word embedding is 300, and it is particularly trained on a very large corpus of Google News. So in some of your work or in some particular, for example, if you're working on one particular problem, you might want to try this out, because this is trained on a much larger corpus, and it is able to encode the word vectors much better. The next thing that I'm going to show you is the similarity between the words. So as I already said, we compute the similarity using similarity between two words by computing the cosine similarity between the two vectors. So this method here is if you provide the two words and the word embedding model, what it will do is it will get the vectors for those two particular models, and it will compute the cosine similarity. So this cosine similarity function is imported from sklearn library. If you have not installed it on particular machine, it is available out of the box in Google Colab. Otherwise, you can install using this particular command. You can install sklearn if you are using a local environment, a local Jupyter network. So if you are able to see here, I have computed cosine similarity for a few words. For example, easy and easiest, and then I have computed with easy and difficult. So from our understanding of the English language, we know that easy and easiest are more similar as compared to easy and difficult. So that also is shown in the similarity. The similarity between easy and easiest is 0.61, and this is 0.58. So what we need to understand is when you are checking the similarity, it is the relative similarity between the words which matters rather than the absolute similarity. So similar relationship is also seen here. For example, India and rupee. So rupee is much more related to India as compared to dollar. So that again is shown in this similarity again here. For example, 0.325 between India and rupee, and between India and dollar we have 0.11. Similarly, another example is mouse and mice and mouse and cat. So you have 0.58 and 0.46 here. So when you actually try to run this particular notebook on your own side, you might not get the exact same results, because it depends on the embedding, how much you have trained, what are the parameters. So these outputs are based on how I have trained this. You might get slightly different results. So the next part which I'm going to cover is word analogy. So I think sir also, Professor Suman Mitra also had covered some things related to this. So some sort of analogy, word analogy is encoded in these particular vectors, which is very interesting. So for example, man is to king. this same representation analogy can be shown using woman and queen. So what we can do is we can compute the nearest neighbor of king minus man plus woman. So when I'm doing this operation, I'm doing this on the vectors. So I get the I use the king vector minus man vector plus woman vector. So I compute the nearest neighbor as nearest neighbor of this particular vector, comparing to the entire vocabulary. And if you see, if you compute this, this particular code is doing here the model dot most similar, and top n means it is giving the first one, the most similar one. If you specify top 5, so it will give 5 outputs. As you can see, it is giving queen. So this is some interesting property which is showed by word-to-vec vectors, which is quite useful, and this shows us that these word embeddings which we have trained are really able to encode some semantic relationships, uh, which are not done by, for example, TF, IDF, or some other representation which Sir had discussed in his lecture. Similarly, I have given another example. For example, boy is brother, girl, sister. I'm doing similar operations, mathematical operation of subtracting and adding the vector. And if you see, if you do top n and 1, and then you see that it is game sister. So this is some interesting property. Yeah. So far I have covered what to make, and if you want to play around with this in your assignments, I suggest you to play around. I also will discuss some things more related to it, on what exactly you're supposed to do by changing the parameters here of skipgram, window size, maybe vary from 5, 10, 15, 20. Change the vector size and play around with it, and you can try to compute the similarities and try to see what actually happens and how the values change. Yeah, so the next thing I want to discuss is fast text. This is I have provided the link to the research paper also. Do read the research paper. It will give you some important insights. So I have specified some of the parameters here. Input is the training file which you need to provide. As opposed to the word-to-vec, you don't need to do any sort of pre-processing. In this, I mean, you need to provide the pre-processed text corpus in a file, rather than providing a list of sentences as compared to word-to-vec. So the file which you have to provide has to be pre-processed, remove the punctuation, lowercase it, whatever pre-processing you have done in your lab sessions or in your assignment so far. So the next parameter is model. Model decides whether we are using the CBAO or the skipgram algorithm. The dimension is similar to the vector size in the previous word-to-vec. The dimension, how much will be the length of the vector. WS refers to the size of the window. In the square brackets, all the default values are given here. Window size is default value is 5. Epochs refers to the number of iterations you are going to train. So the default value is 5. So what usually happens is, since fast text is using character n-grams, it takes much more time as compared to word-to-vec. So usually we train it for not more than 5 iterations. For a large corpus, it takes a large amount of time. For example, if you take a large corpus of, let's say, 10 GB, it might take some 12 to 15 hours depending on the number of threads and the configurations which you make. Yeah, this mean count is similar to the mean count which I explained in the for word-to-vec. So the default value is 5 here also. These two parameters, mean n and max n, are related to the character n-grams. So the minimum size of the character n-grams which we have to use. So for example, okay. For example, if you have a word like occurrences, if you specify the minimum length of character n-gram S3, so it will take three characters together, like OCC, CCU, and then CUR, like this. So this parameter is configurable. You can change these parameters. Max length refers to the maximum length. So based on this mean length and max length, it will generate all the character engrams from this for every word. Negative sampling is the number of negative samples which you will be using. So negative sampling is particularly used because, for example, if I take the example of skip-gram, let's say in your vocabulary you have, it is typically, for example, in the last word-to-vec example I've shown, there was 70,000 words. So in case of skip-gram, you will have an input target word, and then you have to predict its context words. So this is a large classification. So from the approximately 70,000 words, you have to predict which are the context words. So this becomes a huge computationally expensive problem. To do it with the help of softmax function. I think softmax function has been covered by Sir. So a trick which is a negative sampling has been used. What you do is, randomly very few words, for example, 5 or 10 or 20 are used as negative samples. When I say negative samples, these are the words which are not the context words of the target word. And of course, we will have a set of context words related to this. So you only try to optimize the parameters of this particular word, of only of these words, so as to reduce the computational complexity. So this negative sampling is present both in word-to-vec and fast text. If you look at the original paper here, uh, you might get much more better overview of negative sampling there. I will share the. Okay, this is the first version of the paper which has been published. I will also share the second version of the paper. In that, particularly, negative sampling has been discussed, and what was the reason to use negative sampling. Yeah. So next we go to training fast text. So similar to what to make, if you are trying to train on a very large corpus, prefer to use the original C++ code. This is the repository for that. And you need to install fasttext, even in Google Colab or in your local environment if you're using. So people install fasttext is the command. And yeah, next fasttext.train supervise. This is the uh, function we will need to use. Input refers to, as I already discussed, the corpus file. So I have provided the location, window size, the method which we are using, whether it is skipgram or cbound, the dimensions, the number of epochs. So as we had already done for word-to-vec, similar exercise we are going to do of computing the word similarity in this case also. Given the similar example, easiest, easy, for example, something totally unrelated like dog. Then again, India and rupee, India and dollar. Then mouse and mice, mouse and cat. So you can see all the word similarities here. So the more related words have a higher word similarity as compared to relatively unrelated words. The next thing which we are going to discuss is again word analogy, which we discussed in word-to-vec also. So here I've tried to take a different example, just for the sake of just taking a new example here. Yeah. So here we have the countries and their capitals. So if you take Germany and Berlin, then France and Paris. So in fasttext also, this method has been provided analogies. So if you see here, the most similar word or the nearest neighbor of this particular vector is Paris. So we can say that it is like encoding some good representations. Similar is the case with here. But if you see here, the first word is smaller, and the next word is smallest. So you can expect such kind of results because we might It depends on how much data you have trained for the corpus, how much epochs you have trained, what are your parameters. So usually what we do is we empirically try to find out what sort of settings work the best based on your applications. So what are the advantages of using fast text? So for example, we are using character engrams. In addition to the original word, we also use character engrams. And what benefit do we get out of it? I will try to illustrate with this example. For example, I'm taking this word gear shift. And if I try to check the vocab of this, the model which we have trained, this word gear shift is not present. But if you try to get the nearest neighbors for gear shift, you can see we can find some related words like speed shift, shifter, shifts, gears. So however, vector engrams, what it will do is it will take this gear shift word, it will try to compute all the character engrams based on the setting which we have provided, and it will take the sum of the vectors of all the character engrams. So using that, even if we have trained a corpus, even if in our word embedding, if a particular word is not there, but its character engrams are present, then we are able to get some representation. So this is a very good advantage of fast text. Similarly, and one more example is misspelled words. It is very common on social media or any other text that there are some spelling mistake. For example, I have illustrated this case here where the misspelled word of accommodation is there. But even though the word is misspelled, since we are using character engrams, we are getting the related words. For example, accommodations, accommodating, accommodation, accommodations. So this is the advantage of using fast text. So if you have any questions, you can let me know. Otherwise, I will move on to discussing the assignment which you are supposed to do.
Excuse me, sir.
Yes.
Sir, for FastTag, which library you told to import?
I will share this Jupyter notebook. You don't worry. It is fast text. Pip
Okay,
installs
sir.
fast text. Yeah.
Okay, sir. Okay. Thank you,
Yeah.
sir.
Just after this session, I will share this notebook. You can use this. You can also reuse the code here for your assignment as well. Any other questions?
No, sir.
Okay. Okay. Then I will move on to describe your assignment. So your assignment is already available on the Google Classroom. This is the PDF which is describes what we have to do. So what you will do is using a corpus text embedding both the word-to-vec and fast text word embeddings, and then we'll try to compute the correlation of the word pair similarity and try to evaluate how good are your word embeddings. So the first thing which you'll need is the data set. So this is the data set. So this is the same data set which I have shown you in the you can refer to that code and feel free to reuse that code as well. I will share the notebook just after this session. And yeah, so first thing is you need to train the word embeddings, both word-to-vec and fast text. And what I suggest is you try to vary the parameters. So I have shown you how to train using one set of parameters. So I suggest you to vary those parameters like window size, negative sampling, CBOW and skip gram, the number of iterations. So based on the number of iterations you specify, it might take some time from maybe half an hour to 15 minutes to half an hour. So maybe what you can do is for both word-to-vec and fast text, you can of CBOW and skip gram and try to vary maybe window size or iterations, maybe any two parameters, because I know you have a short time. So maybe try to just just any two parameters of this for each word to vec and fast text. Once you have that, you will have the word embeddings with you. So the next thing which you have to do is evaluate those word embeddings using the word pair similarity task. So I have already shown you the word pair similarity. For example, here for every set of words, two words we are computing the similarity. So for example, similarity between easy and easiest is 0.46. So what you have to do is you have to make use of this data set which I've shared here. It is a dar.gz file. You need to extract that file, and you will have a file which is called as wordsim similarity underscore gold standard.txt. So in that particular file, you will have pair of words and a score between 0 to 10, which has been assigned by humans based on how similar are the words. So let's say if two words are extremely similar, it will be maybe 9 or 10. And if they are extremely unrelated, it might be close to 0, maybe 1, 2, like that. So yeah, so it will have at least a set of words line by line. And the format, I believe, is they are tabs separated. So what you have to do is from line by line, you have to read all the pair of words along with their similarities. And then between the words, you need to compute the similarity using the word embeddings. So what for every pair of words in that particular data set, what you will have is similarity score computed using the word embeddings, and then you will have a reference similarity score which is given in the data set, which is from 0 to 10. So using that, you have to compute the Spearman correlation coefficient. So on how to compute the Spearman correlation coefficient, I have provided you a link there. So the what it will take is it will take two lists as input. So one list will be all the scores, reference similarity scores, and another list which you will provide is all the similarity scores which you computed using the word embeddings. So using these two, you have to compute the correlation score, and for that you can refer to this link. This is the documentation for that particular computing for the correlation scores, variable correlation score. Yeah, so I also provided some few links. For example, if you're not familiar with Python list, reading file in Python, I think if you have already used pandas, you can directly use pandas to read this file. It is tab separated, so you can specify the separator and try to read the file. Yeah, regarding the submission, what you have to do is uh, you have to print the result, that is the Spearman correlation coefficient you obtain for word to vec and fast text, and also for the different parameters which you will vary here. So let's say if you do for a word to vec, you generate two set of embeddings. So total you will have four Spearman correlation coefficient values. And yeah, I suggest you to understand, for example, how the similarity scores are varying. For example, if you do CBA, if you do skip gram, how the values are varying for word to vec and then fast text. We have already seen some advantages of fast text. So you can see whether that benefit is also shown in the Spearman correlation coefficient. So based on this, maybe you can write one or two lines of any observations or any conclusion which you have at the end. Yeah. So one more issue which you will which you might face is when you try to find the word vectors for some particular words. In case of especially word to vec, you might not have the word vector, especially in case of word to vec. So you can skip those words and go ahead when you are computing the word pair similarity. For example, any one word in a pair, then you can skip that pair and go ahead, uh, because usually you will face an error. Yeah. So that's about it regarding the assignment, and this is the deadline. based on how much time you have, you can try to vary the parameters and try to see how much parameter variation you are able to do, and then try to get. I will try to suggest at least try to get at least two scores for at least one for fast six and one for what to it. Yeah. If you have any questions, you can ask me. I see some questions. How to do it in Indian languages like Hindi or Marathi. So if you want to train this, I think some word embeddings are available in language. Already pre-trained are available, especially for example, fast text. I believe there might be available for word to as well. So first of all, you need to get hold. You have to get a corpus. Whether it's Hindi or Marathi, you need to have a good amount of corpus so that you are able to train. And you can train using a similar fashion. Any other questions? Okay. Okay. Then if you don't have any questions, or if you have some other questions, or if you face some issue during the assignments, feel free to comment your doubts, difficulties in the Google Classroom. I will try to help you with that. Yeah. So that's it from my side. Yeah. Thanks for your time. Yeah.
Hello, am I audible? Hello.
Yes, ma'am. Yes, ma'am. You're audible.
Okay, okay. Should I share my screen?
Yes, ma'am.
Can you see my screen?
Yes, ma'am, it's visible.
Okay, please let me know, okay, when should I start?
Yes, ma'am, it's visible.
Yeah, I understand. So, should I start now only or there will be some introduction? Hello?
Yes, ma'am, your screen is visible.
Yeah, I understand. Will there be any introduction or I have to start?
Yeah, 1 second, ma'am. Yeah,
Yeah,
once.
yeah.
Yeah, hello everyone. So we will have the next session now, and it is on information extraction by Professor Sriparna Saha from IIT Patna. So yeah, welcome, ma'am. Welcome, and so you may start your lecture now.
Okay, so Chanchal, let me see when or maybe Chanchal would be joining.
I think she has not yet joined.
Not yet joined. Yeah, she would be joining in.
Okay.
Okay, so I hope my screen is visible.
Yes, ma'am.
Yeah. Okay. So good afternoon to all of you. So today's session is on information extraction. So the plan is that I will be teaching 2 hours. So I will take lectures of 2 hours, and then one of my student Chanchal Suman. So she would be showing you some demonstrations. So the codes, some codes, and some assignments she would be given to you. So that is the idea. So I am Dr. Sriparna Saha. So I am currently an associate professor in the Department of Computer Science and Engineering, IIT Patna, and I am also associate in research and development of IIT Patna. So this is my web page. So yeah, I am working in the field of information extraction for a long time. So you can visit my web page to see some recent publications and get to know some other research directions. And this is my email address. So if you have any doubts regarding today's session, you can simply contact me over email. So I hope I am audible and visible. So if there will be any problem in between, if there will be any connection problem, or if I am not audible or my skin is not visible, please let me know so that I can rectify. Yeah, so this winter school is on natural language processing, and you know that natural language processing is having several subtasks. So information extraction is one of the subtasks of natural language processing. So today we will mainly focus on the information extraction. So information extraction and the goals, and then doing what is the general framework and the difficulties of natural language processing. Information extraction is having several subtasks. Like relation extraction, name entity recognition, co-reference resolution, event extraction, terminology extraction. So these are the different subtasks under information extraction. So I will discuss in brief all these subtasks. And then I will show you some applications of information extraction. So in solving the real life problems, we have to do some applications of information extraction. So I will show you some applications of information extraction. So basically information extraction means that from the unstructured data, you have to extract some useful information. Like suppose there is a sentence, the second sign of the zodiac is Taurus. So now from this sentence, we have to extract information that the sign of the zodiac is Taurus. So basically, we will have several of sentences, and from those sentences, we have to extract information that what are the signs of the zodiac. Then most common cause of death in America. So in the text there could be many such sentences. What are the main cause of death in America? So maybe there is an article and the article is having multiple sentences on that. So article reports about the most common cause of death in America. So from the article we need to extract the important diseases and then make a list of those diseases. Like then largest rodent in the world, so like that also we can extract. So basically you can understand that you have a large collection of unstructured text or the web data, and now from the data you have to extract some information. So what is information extraction? Find and extract automatically limited relevant parts of text. So basically we have a text and we have to extract and find the relevant or limited relevant parts of text. So that is basically called the information extraction. So gather information from many pieces of text. So you will be, this is a task of natural language processing. So the input is basically text, and from the text we need to extract some relevant information. So relevant information could be the entities, their relationships, and also their interconnectivity. So produce a structured representation of the relevant information. So we have to extract first the entities which are mentioned in a particular text. Then we have to find out the relationships between the entities. And then basically that way we can develop a knowledge base or the knowledge graph. So the goal of the information extraction is to organize information so that it is useful to people, because nobody is having time to go through the entire document. So if you can develop a structured data like a list like information, or if you can just develop a knowledge base from the data given, then it would be useful for the users. So put information in a semantically precise form that allows further inferences to be made by the computer algorithms. And for the computer algorithms also, if the data is in a structured format, then it would be quite easy for the computer algorithms to extract to basically develop the different models on the same. So this is an example. Suppose there is a paragraph. Okay, this paragraph is given, and now you have to extract information. So suppose we have to extract information on the tie-up. So we have to the relationship, the tie-up one. So the past information we have to extract regarding a tie-up. So for the tie-up, the entities involved are Bristol Sports Company, a local concern, a Japanese trading house. And joint venture company is basically the Bristol Sports tie-on. Then they are basically there is a activity one and there is a amount involved. Now activity one is basically what is the kind of the activity? It is the production. The company name is the Bristol Sports Taiwan Company, and product is basically iron and metal wood clubs. So this way you can understand that there was a paragraph given. Bristol Sports Company said Friday it had set up a joint venture in Taiwan with a local concern and a Japanese trading house to produce golf clubs to be supplied to Japan. The joint venture Bristol Sports Taiwan Company, capitalized at 20 million new Taiwan dollars, will start production in January 1990 with production of 20,000 iron and metal wood clubs a month. So from this paragraph, you can understand that we have extracted information. So we have extracted information about the tie-up. So for the tie-up, the entities involved are Bristol Sports Company, a local concern, a Japanese trading house, Then there is a joint venture company, so which is basically a Bristol Sports Taiwan company. Then they are doing some activity, which is the basically activity 1, and the amount involved is basically $20 million Taiwan dollar. And the activity 1 is what? The production, which is responsible for the production, the Bristol Sports Taiwan company. And what is the product? The iron and metal wood clubs. So generally, in a NLP, there are 4 layers of operations. So one is the morphological and lexical processing. So you have to somehow work at the word level. So you have to find out the, we can have different prefixes, suffixes associated with a particular word. So we need to find out the root form of the word. That is called the lexical processing. Then we have to find out, we have to check whether the sentence is following the English grammar or not. That is the syntactic analysis. So checking the grammar of the sentence or checking the structure of the sentence. Then semantic analysis is basically the checking the meaning of the sentence. And then finally context processing and interpretation. Because a single sentence may not be useful, may not be meaningful, we often have to check the context of a particular sentence. So if I say that I am going to the bank. So now which bank? This bank could be River Bank, or this bank could be a financial organization. So which bank I am referring to? So this ambiguity can only be resolved if you know the context. So if I say that I am going to bank, I will deposit some money there. Then from the context only, you will be able to understand that here the bank is basically a financial organization, and the bank basically here bank refers to the financial entity. So these are the 4 layers of natural language processing, and each layer is having some problem. Like for the morphological and lexical processing, the problem is the incomplete lexicons. So sometimes some words are not present in a dictionary. Some words are new words. Especially if you are dealing with the social media data, then in the social media, people are often utilizing new words. So that is called the incomplete lexicon problem. Then incomplete grammar. So syntactic analysis, maybe a new kind of grammar has been introduced, or which is not known. So basically, incomplete grammar problem is associated with the syntactic analysis. Then maybe sometimes some domain knowledge is absent. So we don't have the domain knowledge. So if we don't have the domain knowledge, then we will not be able to understand the semantic structure well. So we will not be able to interpret the meaning. And then finally, the interpretation. Finally, basically for the context processing, the interpretation rules are sometimes very difficult to generate. So basically, there are difficulties of natural language processing in each and every layer. Sometimes there are some new words. Sometimes the sentence will not follow some any grammatical structure. Sometimes maybe the domain knowledge is not present, so you will not be able to basically understand the meaning of some sentences. The interpretation rules, maybe it is very difficult to generate the interpretation rules. So basically, IE can be considered as a compromise of natural language processing. So first, we have to understand identify the complex words. We have to recognize the multiple words and the proper names. So by morphological and lexical processing, we need to recognize the multiple words and the proper names. Then we can identify the phrases. So we can group the words together to identify the simple noun groups, verb groups, and the particles. Then complex phrases, complex noun groups, and the verb groups. Then there is this events, patterns for events of interest to the application. Basic templates are to be built. So basically, these are called the domain events. And then the merging structure. So templates from different parts of the text are merged. And then basically you can understand the meaning of a particular event or the meaning of a particular person. So these are basically we can do some information extraction. So first is the complex word identification. So with the use of the morphological or the lexical processing, we have to recognize the multiple words and the proper names. Then basic phrases, simple noun groups and verb groups and the particles have to be identified. Then complex phrases, complex noun groups and the verb groups have to be found out. Domain events, patterns for events of interest to the application. Basic templates have to be built. So you have to understand what are the basic template event has to be detected. So you have to generate the template for the same. And then templates from different parts of the text are merged to understand the type of the entity or the event. So there are different tasks of the information extraction, as I mentioned. So the first task is basically called the named entity recognition. So named entity recognition is basically in identifying the entities from the text. So there are different types of entities like person name, location name, organization name, miscellaneous names. So these are the different types of entities, and our task is to identify different types of entities from the text. That is called the named entity recognition. Like IITB is an esteemed institute. So here IIT Patna is an entity. So this is called the detection. There are two tasks. One is to detect, another is to classify. So detection means from a sentence you only have to identify the entities. So like IIT Patna is an esteemed institute. Here IIT Patna is an entity. And the classification is basically classifying the entities into different classes. Like entity could be a person name, entity could be a location name, entity could be an organization name. So like that, IIT Patna is an esteemed institute. Here IIT Patna is an organization name. Then the second task is called the relation extraction task. So finding out the relationships between two or more entities. So two or more entities are somehow related. So understanding the relationship between the two or more entities is basically called the relation extraction. Like Dr. Chandra is daughter of Mahesh Agarwal. Here the person, daughter of person. So this is basically the relationship is basically daughter of. And the Mr. Dr. Chandra and the Mahesh Agarwal are the person names. Then co-reference resolution is another task of information extraction. So a particular name can be, in a paragraph, a particular entity can be referred in several ways. Like Modi is the Prime Minister of India, his cabinet is giving power on new hands only. Here he is refers to Modi. So can we somehow club together or cluster together the entities or the pronouns and the entities which are referring to the same entity? So that is basically called the co-reference resolution. Here Modi and his are basically grouped together because they refer to the same entity. Then there is an event extraction. The thief broke the door with a hammer. So here the event is basically the verb break is the event. So here the verb break is responsible for the event. The agent is the thief, patient is the door, instrument is the hammer. So this way the event extraction is basically having many arguments. So here the verb responsible for the event is basically the break. The agent is the thief, patience is the door, and instrument is the hammer. And the last task basically called the terminology extraction. In terminology extraction, it is basically keyword extraction. So in a particular document, there are many words and the phrases. So we only have to extract the important words which are important for representing a particular document. So those are basically called the terminology or the keyword extraction. So there are many main domains of information extractions are terrorist events. So from the terrorist activities, there are many documents available on the terrorist events. So you can extract information from the same. Joint ventures, then plane crashes, disease outbreaks, seminar announcements, biological and medical domains. So from all these documents, you can easily extract the information. And these are the main application domains of information extraction. So information extraction. So basically, you know, there are several approaches for solving the information extraction problem. So we'll see the task by task. As I mentioned, there are several tasks involved under information extraction. So we'll see one by one. So, but there are several methods for information extraction. So one is the cascaded finite state transducers. So it can be rule based, it can be regular expression based. So basically the automata theory, like the automata theory, the finite state automata can be used to understand the meaning of the sentences or to extract useful information from the sentence. Then there are some classification based approaches like this named entity recognition or the co-reference resolution or the relation extraction. All these are basically classification problems. So basically we can easily deploy some classification algorithms like traditional classifiers like maximum entropy support vector machine, naive-based classifier, or the sequence level models like hidden Markov model, conditional random field. So all these techniques can be used for the classification of the as a method for the information extraction. Then there are some clustering based approaches as well, because sometimes generating label data is very difficult. So basically we can use some unsupervised based approaches for solving the information extraction problem, and the hybrid approach, which is a combination of supervised and unsupervised. So this is the cascaded finite state transducer, finite automata for noun groups. So you can see that it is for this word like John's interesting book with a nice cover. So we can start with the 0 state. Then this is the first is the proper noun. So we can go to the 1 state. Then apostrophe s, we can go to the second state, 2 state. Then interesting is the adjective, we can stay there. Then book is a noun, so we can go to 3rd state. Then with is a preposition, so we can go to 4th stage. In nice, basically article will go to the 2nd stage. Adjective is nice, so we'll stay here. And then cover is a noun, so we'll go to the 3rd stage. And then this is a terminating state. So this way, basically, we can design a final state automata, and then we can follow the state. We can transit from one state to another state to check whether this particular sentence is generated by this grammar or not. So regular expressions, some unstructured pieces of information keep some structure and are easy to capture by means of regular expressions. So like phone numbers, emails, URL websites. So all these are basically, you know, that these are easy to capture by the regular expressions. Some unstructured pieces of information keep some structure and are easy to capture by means of regular expressions. So phone number, emails, URL websites. So we can easily express them by the use of the regular expressions. That way also we can detect some entities from the text. Like this is one example, A is the character A, dot is any single character. Then 3rd bracket ABC means any character in the bracket A or B or C. Then this is not, any character not in the brackets, any symbol that is not A, not B, not C. Star means the quantifier matches the preceding element 0 or more times. Plus means the quantifier matches the preceding element 1 or more times. Question mark matches the previous element 0 or 1 time. And this is or matches one of the expressions before or after this. So these are basically the different types of regular expressions. So then there are some learning based approaches. So this learning based approaches are some statistical techniques and machine learning algorithms. So they automatically learn patterns and models for new domains. So these are basically using some machine learning based approaches for learning of the patterns and the models of the new domains. So as we know that in machine learning, there are different paradigms. So we have supervised learning, we have unsupervised learning, or semi-supervised learning, or weakly supervised learning. So similarly, for solving the information extraction problem as well, we can deploy different types of machine learning paradigms. So there are several approaches which are using machine learning classifiers like support-vector machine, CRF, or neural. Recently, in recent years, deep learning is also become very popular. So deep learning techniques can also be used for solving the information extraction problem. So basically, you know that supervised learning of patterns and rules. So maybe you can give the pattern rules as the features, and based on the rules, it can easily predict, it can easily identify the entities or the relations from the data. Then supervised learning for relation extraction is there. Supervised learning of sequential classifier method like CRF, etc. These are sequential classification. So it identifies the entities in a sequence. So there are several supervised learning algorithms for the same. And then weakly supervised or the unsupervised approaches. So supervised learning of patterns and the rules. So this is to reduce the knowledge engineering. So first we have to extract some rules of the from the data, and then those rules will be used as the features. Like AutoSlog is a method. It is a fast information extraction pattern learning system. AutoSlog here basically syntactic templates or the lexicosyntactic patterns are basically extracted. We have to extract some patterns from data, and then those patterns can be used for identifying the new entities. So from the training data, we can extract some patterns to identify the entities, and those patterns can be used for identification of the new entities. Then learning algorithms like LIEP, they generally generate rules from the annotated text. LIEP, syntactic paths, role fillers, patterns that work okay in training are kept. And LP2 uses tagging rules and the correction rules. The relational learning methods Rapier, rules for pre-filler, filler, and post-filler component. Each component is a pattern that consists of words, part-of-speech tags, or semantic classes. So again, basically all these are rule-based approaches. They are mostly identifying the rules from the training data, and then those rules are basically used as features for identifying new relations from the test data. So now there is a task called the relation extraction. So relation extraction is a very important subtask of information extraction. I have already mentioned. So it is useful in question answering and building knowledge bases from text. Like suppose there is a paragraph like this, Indian Institute of Technology Patna is an autonomous institute of education and research in science, engineering and technology located in Patna, India. It is recognized as an institute of national importance by the government of India. It is one of the new IITs established by an act of the Indian Parliament on August 6, 2008. So here, what are the relations? IIT Patna is an autonomous institute. This is a relation. IIT Patna located in Patna. This is another relation. IIT Patna established by Act of Indian Parliament. Established by, this is one relation. Then IIT Patna established on August 6. The established is basically another relation. So you can understand, we can identify 4 relationships from this particular text. So why relation extraction? So it creates new structured knowledge base. It augments current knowledge base because you know these are the relations. These relationships can be added to the knowledge base. So you already have a knowledge base for the IIT Patna. So these new relations can be easily added to the knowledge base to augment the current knowledge base, and also it supports the question answering. Like for example, the granddaughter of which actor is starred in K3G. So here this can be posed as a question answering problem. Acted in. So this is basically the relationship. So acted in X K3G. So X is a unknown actor and K3G is the film. So the relationship is basically acted in. Then is A is another relationship, X actor. So this is another relationship. Then granddaughter of XY. So this is another relationship. So this basically, you know, we can express the question answering problem as a relation extraction problem. And then a relation extraction can be used to solve the question answering problem. So for example, between two entities, there could be many relationships possible. Let's suppose there is a person and there is an institute. So between the institute and the entity, there are many different types of possible relationships. Like who is the founder of the institute? Who is the investor of the institute? Who is the member of the institute? Who is the employee of the institute? Who is the secretary of the institute? So these way there are multiple possible relationships between the entities and the between the entity and the institute. So this is an entity and this is an institute. So between the entity and the institute, there are different possible relationships. So there is a supervised learning for relation extraction. So design a supervised machine learning framework. So we can design a supervised machine learning framework for identifying relationships from the text. So we can categorize we can identify what are the different relationships types, and those would be the classes. So we have to decide about the relationships that we are interested in. Like here I have mentioned, these are the relationships: founder, investor, member, employee, secretary. These are the relationships. So we can decide about the relationships that we are interested in. We choose what entities are relevant. So we choose the entities which are relevant to each other, like which entities are relevant. Basically, this is called the named entity recognition. By using the named entity recognition, we can extract the important entities from the text. And then we find out the label data. Representative corpus, label the entities in the corpus. Automatic NAR, named entity recognition. Hand label relation between these entities. So we can we have a corpus of data because that is called the training data. We must have a corpus of data which is called the training data. Now we have to label the entities in the corpus. So which are basically the named entities. Those could be location names, organization names, person names, some miscellaneous names. Then we have to hand label the relationships between these entities. So we have already classified the entities into different categories. So we have to hand label the relationships between the entities. And then the data will be split into three portions: training, division, and the testing. So basically the corpus will be divided into three parts: training data, development data, and the testing data. So the models will be developed, will be trained using the training data. And then development data is basically used to fine tune the parameters of the model. And finally, the testing data is basically used to check the performance of the model on the unseen data. So basically, you know, this is a standard machine learning procedure. So in machine learning procedure, the data set is basically divided into three portions: training, development, and testing. So training data will be used for training the model. The development data is used for fine-tuning the parameters of the model. And finally, the testing data is used for predicting the performance of the model on the unknown data. So train, improve, and evaluate. So basically, our task is to train on the training data, then improve the performance on the development data. And once we freeze the model on the development data, that written model can be used to test the performance on the testing data. So testing data would be used for the evaluation purpose. So this way we can apply any supervised learning algorithm for the relation extraction. So it is basically formulated as a classification problem. The different types of relationships are basically the classes. So that we have to somehow understand after analyzing the data. And then we have to generate the training, development, and test data. And we have to build some classifiers on the data. So basically the named entity recognition is very much important. So you can see Google is also using the same concept. So if you search ACM headquarters, Google will show you the Newark, United States, and also people also search for. So basically you can understand this is basically named entity recognition. So if Google will see that Newark is a location name, so it will try to fetch some other location names in USA. So it will try to display the other location names in USA. So this is basically a lower level. So Google search is an information retrieval task, but at a lower level, it is also performing the name entity recognition. So it is not only extracting the keywords from the, it is not only a question answering system. So question answering system is built on the name entity recognition, and also there is a search. Like whenever you are displaying the New York is a location name. Google is also displaying the other location names in the USA. So name entity recognition is basically finding and classifying names in different categories. So from the text can have multiple different entities. So our task is to not only identify the entities, but also to classify them into different predefined categories. Like we have the person name, location name, organization name, and the miscellaneous name. So you have to not only find the entities from the not only find the entities from the text, but we also have to classify them into different categories. So input image, text location. So basically we have to, given an input image, we have to find out the text locations. Then we have to do the optical character recognitions. And then finally we have to apply some name tagger to tag the entities and to assign some class labels to those entities. And then that would be the output. So named entities would be the output. So our task is to find and classify names in different categories. So this is an example of a NAR system. So you know that the decision of the independent MP Andrew Wiki to withdraw his support for the minority Labour government sounded dramatic, but it should not further threaten its stability. When after the 2010 election, Willie Robb, Waskey Scott, Tony Windsor, and the Greens agreed to support Labour, they gave just two guarantees: confidence on the supply. So here the blue names are basically the person names. Then the green name is basically the date, and the this light brown, light orange names are basically the organization names. So basically, this is the task that from the text you not only have to identify the entities, but you also have to classify them into different categories. So uses of name entity recognition. So name entity recognition is having many applications. Name entities can be indexed, linked off, etc. So you know that we can use this name entity recognition for the indexing. We can use this for linking up two documents. Suppose two documents are talking about Taj Mahal. So you can easily extract the entities from the two documents, and then if you see that they're most of the entities are somehow similar, then we can link the two documents. So that way, for the linking purposes, for the indexing purposes, name entity recognition is very much important. Then suppose there is a product review, and you have to understand what are a particular product can have several aspects. So a product, for example, a camera has zoom, resolution, power supply. So there are several aspects of a particular product. So or a mobile phone has the display, the mobile phone has the memory capacity, camera quality. There are several aspects of a particular product. In order to understand what is the sentiment of a particular aspect, you need to first understand the aspects. So this aspect are basically the entities. So for that reason, you have to first understand the entities of a particular aspects of a particular product. So a lot of I relations are associations between named entities. So relation extraction is basically the first step of any information extraction module is the named entity recognition. Because after you recognize the entities, we can only work on the relation extractions. Because relationships are basically between the entities. So for question answering, answers are often the named entities. So in question answering also, for named entity recognition is having a huge application. So concretely, many web pages tag various entities with links to bio or topic pages, etc. So this is an example sequential classification model. So for the name entity recognition, there are two types of taggings possible. So one is basically called the IO, inside outside tagging, encoding, or there is another type IOB, inside outside at the beginning. So we have to tag, we have to basically a entity could be of multiple words, like Sriparna Saha. So Sriparna Saha is a person name. So Sriparna is the first name and Saha is the last name. So basically you can see the person name is having multiple words. There are several entities which are consisting of multiple words. So information extraction is a classification problem using sequential learning models. Decide what you want to extract, represent the annotated data in a proper way. So basically annotation is basically possible in two different ways. Either we have to encode using IO encoding, like here you can see that Fred, Short, Sue, Mangu, Huang's new painting. So here Fred is a person name, Sue is a person, Sue, Mangu, Huang. This is the basically these three are the parts of a person name. So all are tagged as person and others are tagged as O. But in the second IOB, which is the inside, outside, and the beginning, Fred is tagged as the B par, Sue is tagged as the B par, Mengui is tagged as the B par, and Huang is tagged as the I par. So this way you can also have the B par, I par, beginning and the beginning, intermediate, inside, outside, and the beginning. And then once this tagging is done, so those are basically the classes. So for example, here person name, B person, I person, these are basically the class names. So these classes are basically, that now we can easily use any machine learning classifier to classify these classes. So represent the annotated data in a proper way, and then any sequence, because it is a sequence learning algorithm. As you know, it is here context plays a very important role. If Sue is the B par, then the next would be again the B par. So basically this way, next would be the I par. So this way there is a dependency on the previous tag. That's why it is called a sequence leveling task. And the algorithms like CRF and HMM can be useful for solving this tagging problem. And the application is in the part of speech tagging and the NAR. So part of speech tagging and the name recognition are basically some sequence labeling problem. So what is the sequential classifier method? So what are the typical steps for training? Get the annotated training data. So like this way you have to annotate the training data. Represent the data in the IOB format, in inside, outside, beginning format, you have to represent the data. Design feature extractors. So you have to extract the features from this data. So if this is the data, so you have to extract the useful features from the data. Decide the algorithm to use. So which algorithm to use? The algorithm could be HMM, CRF, or any classifier, any deep learning classifier can also be used. So you have to decide about the algorithm to be used. And then using the training data, we can build the model on the training data, and we can develop the model, and that pre-trained model can be applied on the testing data. For the testing data, get the test documents, extract features. We have to manually extract some useful features which are important for the classification purpose. Run the sequence models, extract the recognized entities. So these are basically, these are the steps of the classification. What are the features important for the relation extraction? For the relation extraction, there are several different types of features that are useful. Like what features? Head word. So head word are the important words. Like in a particular word, especially in the biomedical field, there are several in the biomedical field, entities are nothing but a multi-word entity. So some words are important. So those words are basically called the head words. Bag of words, all the words present in the entities. Word diagrams, so at a time you can consider only 2 consecutive words in specific location. Bag of words are the diagrams between the 2 entities. So these are the word features. Then we have the named entity features. like named entity types, concatenation of the two entity types. So you have the basically what are the entities, what you know the words, whether that is an entity or not, whether that is a person name, location name, or organization name or not, and concatenation of the entity types. Then base syntactic chunk sequence. So you know chunking, chunk is also very much important. So we can understand the chunking information of the words. Then constituents parse and dependency parse. These are basically generate the parse tree base. These are some parse tree base information. They give us the syntactic structure of the sentence. So those path based features can also be added. And then apart from that, we have also gazetteers in the trigger list. So there are some dictionary. Suppose we have a domain knowledge and we know that some words should belong to a particular class. So that dictionary, we can also use the dictionary as a gazetteer, and we can check whether an entity is belonging to the dictionary or not. If the entity belongs to the dictionary, then that can be added as a feature. So basically, you know, different features can be used for making patterns in order to extract relations. So for the relation extraction task, we can use different sets of features. So advantage is that this is accurate and precise, can be tailored to domain specific. Basically, you know, these rules are mostly domain specific. So the features that we are going to extract are basically domain specific features. Disadvantage is a lot of human knowledge designed separately for each entity. So basically, you know, relation extraction, if you are solving as a classification problem, then we have to extract several features, and these features are mostly domain dependent, because in the biomedical field, we have to focus on a set of features, but in the normal news domain, maybe we have to focus on some other set of features. The features are very much domain dependent, and we have to design separately for each entity. And there are some classifiers for the supervised method. So there are several classifiers available on the, and those can be used as a supervised method. We can extract the features depending on the domain and depending on the requirement. And then we can apply any classifier like naive-Bayes or subprefect machine or the maximum entropy. These are the popularly used machine learning classifiers for the task of relation extraction. Now about the performance evaluation. So how to evaluate the performance of a named recognition system or a relation extraction system. So suppose this is the thing that this is our collection of documents. So we have a large collection of documents, and now basically we are focusing on only N. So N is the correct documents. So basically we are now focusing only on the N number of documents. And suppose capital M is the retrieved set of documents. So our system is able to retrieve only capital M number of documents. So amongst them, the C are correct because C belong to N. So then there are three measures called the precision, recall, and the F measure. So these three metrics are basically used to check the quality of the classification system. So precision is basically equal to C by M. So total M number of documents are retrieved. Out of them, only C are correct. So precision is basically C by M. Recall is basically C by N. So there are initially total N number of documents, out of which C are correct. So recall is basically equal to C by N. And F measure is basically harmonic mean of recall and precision. This is the harmonic mean of recall and precision. So 2 into P into R by P plus R. This is the harmonic mean of recall and precision. So the supervised relation extraction has many pros and cons. So pros is the higher accuracy, because any classification system is more accurate than any rule-based system. So this is more accurate if enough training data is present. Cons is labeling training data is expensive. So you know that labeling training data is very much expensive, because you understand that we need to generate a huge amount of training data, and that also to annotate data. Annotation of data is very much expensive. So that is a cons. Don't generalize well on different genres. So basically, you know, it is very difficult to generalize well on because a model can be developed for a particular domain. So for each individual data, we have to generate different models. So models are not very much generic because features are very much dependent on the domain, application domain. And IE is quite domain specific, no reuse. So then there are some semi-supervised based approaches for the relation extraction. So we have the seed-based relation bootstrapping, DAIICT, and the distance supervision. So what is the semi-supervised method? The seed-based relation extraction module. So small training set with a few seed pairs and high precision patterns. Use the seeds to directly learn to populate the relation. So basically here a small training data is basically used, and we have to use a few seed pairs and high precision patterns we have to use. These seed pairs have to be used to directly learn to populate the relation. Like Mark Twain Elmira, this is a seed tuple. Now we can search this seed tuple in the training data. So suppose with training data, there are several relationships like basically Mark Twain is buried in Almira, New York. The grave of Mark Twain is in Almira. Almira is Mark Twain's final resting place. So we have to grab for the environments of the seed tuple. So we have to search where Twain and the Almira both are present. Then these kind of rules we have to extract, that X is buried in Y, the grave of X is Y, or Y is X final destination. So all these are called the patterns. So our seed was Mark Twain Elmira. We know that there is a relationship exists between Mark Twain and the Elmira, and we use that as a seed. And by using the seed, we are extracting basically the patterns between two entities. So Mark Twain and the Almira are two entities. What are the possible types of relationships between these two entities that we are extracting from the training data? So these are the patterns, that X is buried in Y, the grave of X is in Y, Y is X final resting place. So these are the different patterns, and we have to use these patterns to grab the new tuples. So then there is the semi-supervised method DAIICT. So this is just a different because in seed-based relation bootstrapping, we are only using a particular seed for identifying the patterns. But in case of DAIICT, multiple seeds are used. So for example, we can start with 5 seeds. Isaac Asimov, the robots of like the authors in the book. So we can start with 5 seeds. Isaac Asimov, the robots of Dawn, Dawn, the David Brain, Star Trek Rising. So these are the different authors and the corresponding books. So they are basically the seed data. And by the use of this seed data, we can identify the relationship pattern. So we know that relationships exist between the author and the book. And these are some entities which we already know. Some entities in the author category, some entities in the book category. So these are the different instances, different type seeds. Now we have to find out the patterns between these two entities. The Comedy of Errors by William Shakespeare was, the Comedy of Errors by William Shakespeare is, the Comedy of Errors, one of William Shakespeare's earliest attempts. The Comedy of Errors, one of William Shakespeare's most. So these are the different instances. So we can find exact patterns grouped by mutual take longest common prefix or suffix, like question X, comma, by question Y, or question X, one of question Y. So this way we can easily find out the patterns from the data. So these are the patterns present in the training data to develop the relationships between two entities. And now we can use these patterns to determine the new relationships or new entities and the relationships between them. So these are the patterns which are responsible for the relationships. So these relationships can be used to identify new relationships or the new entities from the text. Now there is a semi-supervised method as well, which is called the distance supervision. So bootstrapping plus supervised learning. large number of seed collection using large databases, lots of features using these seeds, supervised classifier on the collected seeds. So basically, you know that here the seeds are basically used to find out the patterns, and then those patterns can be used as a features. So basically, patterns are first found out by using the seed data, and then those patterns can be added as a features for training of a classifier. So this is a semi-supervised thing. So a large number of seed collection using large databases, lots of features using these seeds, and then supervised classifier on the collected seeds. Then there is also an unsupervised method for relation extraction. So this unsupervised method of relation extraction is basically called the OpenIE. So the system first splits each sentence into a set of entail clauses. Okay, the system, like born in a small town, she took the midnight train going anywhere. So here first it is split into the several entail clauses, like born in a small town, she took the midnight train going anywhere. So these are the clauses. Each clause is then maximally shortened, producing a set of entail shorter sentence fragments. These fragments are then segmented into OpenIE triplets and output by the system. So this is the input. So she took the midnight train going anywhere. She took the midnight train. So this is the shortened version. So she took the midnight train going anywhere. This was the original sentence. And now we have the shortened sentence. She took the midnight train. Then born in a small town, she took the midnight train. So here the shortened thing is that she took the midnight train. So then we are generating then she born in a small town. So here the shortened sentence is basically she born in town. So then we are generating triplets, like from this born in a town, she took the midnight train. Here the triplet is she took midnight train. And then she born in town. Here the triplet is she born in town. So basically, you know that these are the pairs of relationships. Now there is another task of information extraction. As I mentioned, that information extraction. The first task is the entity recognition. The second is the relationship extraction. And now thirdly, there is an important task which is called the co-reference resolution. So co-reference resolution means that multiple entities are somehow co-referring to each other. So like like in a particular sentence, a particular entity can be referred in several different ways. Like Dr. Sriparna Saha can be referred to as Dr. Saha, Dr. Sriparna, or only Sriparna, or she, like that. So how to identify all the entities or all the instances which are referring to the same entity? So determining all referring expressions that point to the same real world entity. And so this is called the co-reference resolution. A grouping of referring expressions with the same referent is called a reference chain or a cluster. Okay, so like this, Dr. Sriparna Saha, Dr. Sriparna, Dr. Saha, or only Sriparna, or she. So all these refer to the same entity. So all these would be put into a same single group, and that is basically called a cluster. A grouping of referring expressions with the same referent is called a co-reference chain or cluster. Like Paul Allen was born on January 21, 1953 in Seattle, Washington, to Kenneth Sam Allen and Edna Phi Allen. Allen attended Lakeside School, a private school in Seattle, where he befriended Bill Gates, 2 years younger, with whom he shared an enthusiasm for computers. Paul and Bill used a teletype terminal at their big school, Lakeside, to develop their programming skills on several time-sharing computer systems. So here the Paul Allen, he, and this Paul, they refer to the same entity. So you can see those are grouped together. all those are that put the number, or for all these that we put the number 0. Then Seattle, so all these are basically grouped together. We put the number 1 for all these. Then Bill Gates and Bill, these are same entity, so we put the same number. Then this they are referred to the same person. Basically, this Paul and Bill together, that is basically there. So we are putting this number here. This is called the co-reference resolution. So finding out the co-referring entities together. So there are several ways of co-reference resolution. So one is called the mention pair model. So determine whether two mentions are co-referent or not. Like given Paul, Allen, and Allen, we have to extract all the entities and all the pronouns from a particular text. So by using the name recognition, we can extract all the entities, and by using the part of speech tagger, we can identify all the pronouns from a particular text. Then we can consider all the pairs, and we can check whether those two pairs are co-referring or not. Like Paul, Allen, and Seattle are not co-referring, but Paul, Allen, and the Allen are co-referring. This is called the mention pair model. Determine whether two mentions are co-referent or not. Then there is a mention ranking model. By searching among a group of mentions, the best candidate for desirable mention is determined. So basically, we have to search that Paul Allen can be grouped with which mention. So it cannot group with Seattle, but it can easily group with Allen. Again, it cannot group with Seattle, but it can group with he. So this is called the mention ranking model. By searching among a group of mentions, the best candidate for desirable mention is determined. And third is the entity level model. Categorize each mention with the previous entity. So we have to see whether a particular entity referred to the previous entity or not. Like Seattle is not referring to the Paul Allen, but this Allen refers to the previous Paul Allen. Here this Seattle refers to the previous Seattle. He refers to the Allen. So this way, we can have an entity level model, categorizes each mention with the previous entity. So this is the ways of co-reference resolution. Then there is another task of information extraction. So which is basically called the event extraction. So whether from a particular document, from a particular document, what are the events mentioned? So the process of gathering knowledge about periodical incidents. The process of gathering knowledge about periodical incidents found in text. So the process of gathering knowledge from periodical incidents found in text is basically called the event extraction. So automatically identify information about what happened and when it happened. So basically event extraction is the process of gathering knowledge about periodical incidents found in text. So it is the automatically identifying information about what happened and when it happened. Example, President Donald Trump's government banned countries from importing Iranian oil with exemptions to 7 countries. Then second event could be US Secretary of State Mike Pompeo announced that his country would open no more exception after the deadline. So connect time distributed events and assimilated their effects, and how a set of episodes unfolds through time. So this is called the event extraction. So the process of gathering knowledge about periodical incidents found in text. So what are the methodologies of the event extraction? There are mainly 2 types of methodologies for event extraction. One is called the data-driven process, and another is called the knowledge-driven process. So one is basically extracting information from the data. So based on the data, based on the statistical properties of the data, depending on the probability, etc., we can extract the events. Approaches focus on discovering statistical relationships. Facts that are supported by statistical evidence. Basically, we have to extract only those events which we will say that only those events are important, which are statistically, validated. So if the data will support a particular event, Then only we will extract that particular event. And then there is a second step which is called the knowledge-driven event extraction. It is based on patterns that express rules representing expert knowledge. So we already know a particular event. So we can easily, from our knowledge base, depending on the domain knowledge, we can find out a pattern that this should be a pattern of an event. And then that pattern can be used to search for the new events. It is inherently based on linguistic and lexicographic knowledge, as well as existing human knowledge regarding the contents of the text that is to be processed. So these are the two methodologies of event extraction. And now there is a terminology extraction as well. So which is called the keyword extraction. This is also named as the keyword extraction. So keyword extraction is basically extracting important phrases or the words from a particular document. A text analysis technique that automatically extracts the most used and the most important words and expressions from a text. It helps summarize the content of text and recognize the main topics discussed. So basically, for the summarization point of view, keywords extraction is very much useful because keywords are the most important parts of a particular document. So if you can basically extract the keywords, based on the keywords, we can categorize the our document, and then keywords are also important for identifying the main theme of the document. So the keywords can be useful for summarizing the document. So it helps summarize the content of text and recognize the main topics discussed. So basically it helps in finding keywords from all manner of text. So the documents could be of different types, like it could be regular documents or the business reports, social media comments, online forums and reviews, news reports and more. Like, if this is the document, the look is very stylish. Although battery life is less than the standard one. Camera is good. The best thing is lightweight and fast. So from this paragraph, we need to extract the keywords. So what are the terminology of the keywords? Look, battery, camera, lightweight, stylish, fast. So these are basically these are the different keywords associated with this particular paragraph. So there are several advantages of keyword extraction. To find valuable insights into topics your customers are talking about. So keyword extraction is playing a very important role to find valuable insights into topics your customers are talking about. There is advantages for scalability, consistent criteria, real-time analysis, because as I mentioned that for summarization or for the event monitoring, keyword extraction is very much important, because for summarization you have to understand the type of the document, and the topic type of the document can only be understood if you can extract the keywords. So based on the keywords, you can basically predict the type of the document. And then once the type is predicted, we can summarize the document well. There are several use cases like social media monitoring, brand monitoring, customer service, customer feedback, business intelligence, search engine optimization, product analysis, knowledge management. So there are several use cases of keyword extraction. So keyword extraction is heavily used in social media monitoring, because you know that if you have to monitor the social media, you have to basically check what are the main contents of the social, what the people are talking about. So that is nothing but the keyword extraction. Then brand monitoring. So if you want to understand the review of a particular brand, again you need to find out the keywords. So there are several use cases of the keyword extraction. So there are several methodologies for the keyword extraction. One is basically called the statistical approaches, which is based on the word frequency. So the words, basically you can calculate the TF, IDF vectors. You know, TF means the term frequency and IDF is the inverse document frequency. So based on the term frequency and the inverse document frequency, we can easily calculate whether a word is important or not. So depending on the word frequency, word collocations and the co-occurrence, we can easily understand whether a particular word is important or not. So that is basically one, and that is the statistical approach. So based on the key term frequency, inverse document frequency, based on the frequency of the words, we can easily understand whether a particular word is important or not. Then there is this rapid automatic keyword extractor RAKE, which is a very important methodology available for the keyword extraction. Then we can also use the linguistic approach, like by using the part of speech information, dependency parser, morphological or syntactic information. We can easily extract whether which words are more important, and those would be the keywords. Then there are several machine learning based approaches as well. So the machine learning based approaches will be able to extract the keywords from the given document. So in the next, I will show you some applications for information extraction. So please let me know if you have any questions, because I am continuously teaching. So just let me know if you have any question regarding this portion. Hello, am I audible?
Yes, ma'am.
So any question till now?
Ma'am, one thing I want to ask, that you have taught right now methods of information extraction. There was one method, hybrid approach. Ma'am, I want to know the combination of hybrid approach. Which two method we used in that?
So hybrid approach is basically, like I mentioned now, that suppose you determine the rules. Okay, you have the domain knowledge. So based on the domain knowledge, you determine the rules, and now those rules can be easily used as a features. Okay, so you know that like I mentioned in the relation extraction, that you have the seeds. So based on the seeds, you expect some patterns from the data. Now those patterns can be used to generate some features. So this is basically a hybridization between the rule-based system and the classification system. Okay. So
Okay, ma'am.
this is one example. Like there are all the semi-supervised methods are basically some hybrid approaches. So hybrid means combination of multiple approaches. So you can combine the rule-based approach with the classification approach, or maybe some portions are basically unsupervised and some portions are supervised. That way also you can make the hybrid approaches, or maybe you are somehow combining 2 or 3 classifiers together. Okay, so in some portion you are having say, SVM, some other portion you are having CRF. So that way also you can make it hybrid.
Okay, ma'am. Ma'am, one more thing.
Yeah.
Ma'am,
Yes, please.
in cascading finite state transducers, we have used finite state algorithm. That's kind of a machine, na ma'am?
Yeah, it is a kind of a machine, yes. So basically this is a kind of a rule only. Okay, it is a kind of a rule. From the implementation point of view, it is a rule that the states are basically by using this age links, you can define some rules. So this is basically a display of the rules.
Okay, ma'am, the rule is based on the nouns now. When noun encounter in a stage, we move on to the next transition state.
Yeah, the rules are basically based on the part of speech tags.
Okay, ma'am.
Yeah, not only nouns, but other part of speech tags are also there. Pronouns, article, all those were there. So rules are based on the part of speech tags.
Okay, ma'am. Thank you, ma'am.
Yeah, so then let us please now basically I will show you some applications of information extraction. Okay, so till now I was giving you a basic idea of information extraction. So what is basic information extraction? Basic information extraction. What are the different tasks involved for the information extraction? Now I will show you some advanced information extraction procedures and some applications. Basically, in recent years, my students have done some applications of information extraction. So I will show you some of those. Let me share my screen again. So hope my screen is visible.
Yes, ma'am.
Yes, ma'am.
Yeah, so basically, you know that I have already mentioned that information extraction is basically to extract information that fits predefined database schemas or templates specifying the output formats. Okay, so basically there are information extraction definitions. So there will be an entity, an object of interest such as a person or an organization, attribute, a property of an entity such as name, alias, descriptor or type, fact, a relationship held between two or more entities such as position of the person in company, event, and activity involving several entities such as terrorist act, airline crash, product information, etc. So these are the definitions. So basically these are the information extraction definitions. So we will have an entity, then entity will have several attributes, then there will be some relationships between two entities, two or more entities, and then there will be events, such as event is consisting of multiple entities. So for example, suppose this is a text. Okay, this is a text. Now from this text we have to basically extract some entities. So what are the entities from here? Like this is the date, this is the time, this is the location, this is the speaker, and these are the person names. Okay, so you can understand these are the basically different types of entities present in a particular text. So the full task of information extraction. So information extraction is basically having 4 tasks. One is a segmentation. So you are given an entire big paragraph. Now you have to first segment section by you have to basically a big document will be segmented paragraph by paragraph. Okay. Then there is a classification. So you have to basically classify whether we have to basically classify what are the entities, what are the different type, what are the category of these entities. Okay, then association. So you have to associate an entity with the other entities, and then finally you have to put them into the clusters. Like segmentation means here that this first paragraph is a segmentation, second paragraph is a segmentation. Then there are 4 segments. Now Microsoft Corporation CEO Bill Gates. So these are the entities extracted from this first paragraph. Gates, Microsoft, these are the entities extracted from the second paragraph. Bill Victi, Microsoft VP, these are extracted from the third paragraph. And Richard Stallman, founder, Free Software Foundation, these are extracted from the fourth paragraph. And now we can associate like this Microsoft are somehow they are same. So basically we can associate to each other and we can form a cluster. Similarly, this Bill Gates and the Gates are same. So we can basically make them into a same cluster. So basically you see that this way we can extract information. Finally, our structured data will look like this. Bill Gates is the CEO of the Microsoft. Bill Gates is the VP of the Microsoft. Richard Stallman is the founder of the Free Soft. This way our structured data will look like. So what are the rough accuracy of the information extraction? So in general, in the existing literature, the entity extraction is having the accuracies of 90 to 98%. Attribute selection is having the accuracies of 80%. Relation extraction is having the attribute accuracy of 60 to 70%. Event extraction is having the accuracy of 50 to 60%. But the problem is that the error cascade. So error in entity tag will propagate to the relation extraction, because I mentioned to you for the relation extraction, the first task is the name entity recognition. So first you have to identify the entities, and then only you can find out the relationships between the entities. So basically there will be some error in the entity recognition. So that will be propagated back to the relation extraction module. So this is called the cascading of errors. So the errors in the entity category, named entity category, will be propagated back to the relation extraction module. Similarly, relation extraction module, the errors in the relation extraction will be propagated back to the event extraction module. So this way there is a back propagation of the errors. So these are very rough, actually optimistic numbers. hold for well-established tasks, but lower for many specific or novel IE tasks. Now I will show you some applications of information extraction. So in recent years, we are working on different information extraction applications. So three such tasks are authorship identification, authorship verification, and the authorship profiling. So authorship identification means, suppose there is an unknown text. So can you somehow identify the author? So suppose this is very much important from the forensic authorship analysis. Suppose there is a suicide case and now there is a suicide note. So can you say that whether the suicide note is genuine or fake? So whether the same person who has died, well, he has written the suicide note or somebody else has written the suicide note. So one thing is the handwritten recognition, but nowadays people are using the digital mediums to write, write in a digital way. So in that case, you have to somehow find out the style of a particular author. So from the author's emails, from the author's SMS, from the author's written documents, you have to somehow understand the style of a particular author, and then you have to check whether in the unknown document the same style is present or not. So authorship or forensic authorship analysis is the process of examining the characteristics of a question text in order to draw conclusions on the authorship. So basically there are three tasks. Authorship identification. So given a particular text or a document, you need to identify the author of the particular document. Then the second is the authorship verification. So as I mentioned that you collect a person's many documents. You collect the person's messages, emails, blog post, or several documents which are written by the author. And now there is an unknown document. You have to say whether the document is written by the same author or not. This is called the authorship verification. And then there is a third task, authorship profiling. So the author has many attributes. Like the author is having a gender, author is having an age, author is having an occupation, author is having a fame. So can we predict the profiles of an author from the data? So these are the three tasks. So authorship verification is basically has the probable suspect written the document. So that is called the authorship verification. Authorship identification is basically identifying the particular author of a particular document. And the author profiling is the profile of the suspect. So you have to predict, you have to identify the profile of the suspect. The profile means the gender, age, fame, occupation, personality, etc. So you have to find out the profile of a particular suspect. So these are the three tasks: authorship verification, authorship identification, and the author profiling. So there are several applications of this task. In your internet, the harassment and the spamming is going on very rapidly. So how to understand whether a particular blog post has been written by the authenticated author or it is a fake blog post. So there are several applications of this authorship profiling. So basically we are working on a project which is a very interesting project by Government of India. So Ministry of Information Technology has given us this project. This is a part of the Digify toolset. So here our task is that suppose you have a subject files like emails, tweets, Facebook posts, WhatsApp messages, and there are suspect documents like reference data, emails, text, social media posts collected from field, suspect, victim, etc. And now we have to verify. We have to verify the suspect. You have to identify the suspect. You have to find out the profiles of the suspect. So the analysis report will have the suspect verification, suspect identification, and suspect's profile. So basically authorship analysis of the suicide notes, ransom notes, and the tweets. This is the task. So now first we will discuss about the authorship verification. Task of accessing whether a specific individual writes a suspicious text or not. So this is our task that we know already there are some known documents of the particular author. So now we have to somehow predict the style. We have to somehow understand the style of the particular author, and then we can apply the model on the unknown text, and we can see whether the same style is present in the unknown text or not. If the same style is present, then we will say yes, the unknown document is written by the same author. Otherwise, if the style of the author and the unknown document is different, then we will say no, that the unknown document is not written by the same author. So the task of assessing whether a specific individual writes a suspicious text or not. This is called the authorship verification. There are several data sets available, like RCB dataset, C10, which is a 10 documents of 50 authors in training and test dataset. Then C50, 50 documents of 50 authors in training and test set. US politician dataset, where we have around 12 lakhs tweets, 545 users. Then we have PAN datasets, very few tweets per user, approximately 10 tweets per user. And then ISOT dataset, where we have tweets of 100 users. There are many existing works available. So, but there are very less number of works using basically deep learning techniques. In this particular work, we have developed a deep learning based architecture for solving the authorship verification problem. So basically, you know that the problem is that if you have to generate the handcrafted rules, the handcrafted features are very difficult to generate, because identifying the styles of a particular person by extracting the features is very difficult. So handcrafted features for representing a document is very difficult, and we have to somehow find out the similarity between the known document and the unknown document. So here, in the authorship verification, the task is that you already have some documents written by the same author, and you have to now make a comparative study whether the unknown document is very much similar to the known documents or not. So for that thing, a Siamese architecture is basically used. Siamese network is a neural network having two or more identical subnetworks used for comparing two objects. So basically, you know, Siamese is basically comparing network. It basically compares two text and it will say whether these two objects or the two texts are identical or not. So it learned by embedding of the input documents or images so that it can learn semantic similarity. So there is no need to provide any handcrafted features. It will automatically extract some useful patterns from the data. So you know it is a deep learning based architecture. So it has the capability of extracting useful patterns from the data. And that way you can basically check the similarity between two documents. And basically what is our main proposal? So our main proposal is that when you are comparing the tweets of two people, you should not only compare the text portion, but also the emojis posted by the user. Because sometimes a particular user is more is popularly using some emojis. So by checking the similarity in the emojis, we can also identify the author. So emojis require less typing efforts, less vocabulary, and help in attracting people. Selection of emoji reveals the signature of a particular user. So in order to learn the more specific style of the suspect user, a separate model is designed for each of the user. So basically, our architecture is not only based on the text, but also on the emoji. So we collected a data set. So because there is no existing data set where emoji is also present. So most of the data sets are only based on text, but our data set is based on text and emoji both. So there are very small amount of emoji. So we collected tweets of 108 famous celebrities from different categories till May 2019. Then we clean the tweets to remove the noise in the data. So like retweets, common spelling mistakes, hashtags, special character and character from language other than English. So those are already removed to clean the tweets. Then we generate the training and testing data, like 450 is the training data and 50 is the testing data. Then we preparation of the data for the Siamese architecture. We prepare the data set for the Siamese architecture. So these are some examples tweets. Like you can see that Madhuri Dixit, these are the usernames: Madhuri Dixit, Farah Khan, Ronit Boshroy, Rama Rajeshwari, Karan Johar, Boman Irani, and these are the tweets by them. So this is our proposed architecture. So you can see these are the tweets and these are the emojis. So each for a particular for a particular tweet is having two components: text portion and the emoji portion. So we are considering both the components. Then these the words are basically passed through the LSTM, and then we are getting the text features. Similarly, for the emojis, there is a separate LSTM architecture, so which are giving us the emoji features. Those are concatenated together, and then concatenated vectors are passed through the softmax layer to predict the output class. The words and emojis are fed to the LSTMs for finding the encoded representation. The features from the sub-branches are concatenated for generating the representation of the tweet. So the tweet is having now the text portion and the emoji portion, and and text is passing through one LSTM, emojis are passing through the other LSTM. We are getting the text representation from the tweets and the emoji representation of the tweets, and then we are concatenating them together to get the tweet representation, and then pass through the softmax layer. The concatenation of both tweet representation for gathering for generating final tweet vector. The tweet representation is passed through the hidden layers. And finally, softmax assign the scores to the output class. So we have some baselines. So here, this is the only text-based portion, so where emojis are not considered. So in this case, only two tweets are considered and their text portions are considered. And then we are passing through the LSTMs to generate the text vectors. And then we concatenate them together and pass through the softmax layer. And here it is a multimodal architecture where emoji and the tweet text both are considered. So there is one LSTM separate for the text portion, one LSTM separate for the emoji portion. And these are the different variants of our proposed approach. So initially, in the previous case, concatenated features are only passed through the softmax, but now we have put some layers in between. So the concatenated features are passed through some layers of layers of neurons, and then finally we are predicting. Here there are two layers, here there are three layers. So these are the results, different models and the results. So you can see that our model 2 is giving us the best result. So it is giving around 69% F measure and around 61% accuracy. So baselines are if the quotient similarity between two tweets is greater than 0.5, the result is yes, otherwise no. The word embedding factors of both tweets are passed through different machine learning classifiers. So we also created different baselines. In the first baseline, we check the quotient similarity between the two tweets. If the quotient similarity is greater than 0.5, then we consider that the tweets are written by the same author. We identify the verification equal to yes, otherwise verification equal to no. The word embedding factors for both tweets are passed through different machine learning classifiers. So these are the results. So as a machine learning classifiers, we have used the decision trees, random forest, AdaBoost. And you can see our algorithm model 2 is giving us the best result of 61% accuracy. So error analysis we did. So basically the fast error is because we have very limited number of tweets per user. So it is very difficult to understand the style of a author based on this limited number of tweets. We have small number of tweets per users of the negative class. Out of vocabulary words. So basically many words are out of vocabulary, many words are not, there is in the dictionary, many words, it is very difficult to get the embeddings of many words because there are several out of vocabulary words. The similar words are emojis in the tweet pairs. Many tweets are very much similar in nature and they are also short in nature. So that way many tweets or words are similar in multiple tweets. Now the second task is basically called the multimodal auto profiling or the gender prediction. So predict the gender of the user given its tweet feed. So given the tweet feed, like given the text and the image, can we say what is the gender of the user? So this is the task that you have the tweets and now you have to develop a model to predict whether this tweet is written by a male user or a female user. So given the text and the images, and here the novelty is that we are not only considering the text portion, but we are also considering the images which are associated with the tweet. So given the tweet and the text and the images, we want to determine the user's gender. So we did a thorough literature survey. So there are several works on gender prediction. So we did a thorough literature survey, and then this is the motivation. So basically we have seen that there is no attention-based framework, because attention will help us to put emphasis on particular words or particular portion of the image, because in a given tweet there are only multiple words. All the words are not important for predicting the gender of the user. So only few words would be interesting. So there is very less number of work where attention is used for fusing the text and image modalities. Attention solves the long-range dependency problem. Selectively concentrate on one or few things while ignoring the others. So basically, not all the features are important. We need to focus on few features which are important for gender prediction. So that is the motivation of this particular task. So we, as a data set, we have used the data set of PAN 2018. So in the PAN 2018, there are 100 text and 10 images for 4,900 users. So this is the distribution. For the Arabic data set, we are having 1,500 users. For English data set, we are having 3,000 users. For Spanish, we are having 3,000 users. And number of users in the test data for the Arabic is 1,000. For English is 1,900, for Spanish is 2,200. And that way, this is the distribution of the data. These are some samples, like for the female, these are the samples and these are the images. Two big women, kind, holding breath, pretty, proud, keeping jar blinks, art up long. So these are some instances which are written by the females. These are some instances which are written by the male, and these are the corresponding images associated with the tweets written by the male. Students need good story, laugh following story rolling, cool things happening college. So this way, these are the some tweets which are written by the male users. So we proposed again proposed a deep learning based technique. So because there are two modalities, one is the text modality, another is the image modality. So we need to have two subnetworks. So one subnetwork is responsible for extracting features from the tweet text, and the other subnetwork is responsible for extracting features from the image text. So there are two subnetworks. So one network is for encoding of text, and the other network is for encoding of images. And then we are concatenating them together. We are getting the image text representation and the image representation. We are concatenating them together and then passing through the fully connected layer, and finally the sigmoid layer to predict whether this particular tweet feed is written by the male author or the female author. So we use the attention module. So basically, when we are concatenating, we are putting some attention. So we are discarding some important. We are focusing on the important portion. So BiGRE is used for generating text representation for all the 100 tweets, and ResNet 50 is used for finding image features for all the 10 images. Weighted attention is applied for fusing the text and the image modalities. Okay, so we have used the weighted attention module for fusing the text and the image modalities. Finally, sigmoid is applied for finding the class level. So this is the system. So basically, with only the text. So if you are considering only the text information, then we are getting around 80% accuracy. With only image, we are getting 80.28% accuracy. Then if we are putting the text and images together, direct concatenation, then that gives us 82.20% accuracy. And when we are having the weighted attention, like we are putting the attention on the text and image modality both, we are getting the accuracy of 84.03%. So basically, attention and the text and image modality both helps. So we also compared with the existing techniques. Like in the existing technique, there are some SVM based technique and there are some CNN based technique. So text with features on SVM was giving 82.1%, text with CNN was giving 80%, and our proposed approach is giving basically 84.03%. So we also did some analysis, like after getting the results, we analyzed the results, that what type of tweets are mostly written by the female users and what type of tweets are mostly written by the male users. So like our analysis shows that tweets posted by male users mostly contain political contents, textual contents, money or technology or science related discussions. Tweets posted by female users mostly contain food items, discussion on the food items, discussion on the emotional natural scenes, baby or personal life. And multimodality, like the image information, indeed helps us in correctly predicting the confusing users. Because sometimes text may be the same. So text written by the male and the female are same, but by seeing the images, we can easily infer whether the particular author is male or female. Because there are a lot of common words, mixed type of contents. So in that case, images can help us to predict the author. So these are the words used by male and female, like male using sports, drive, match, versus, play, man, team, etc. Then political words like republic, Trump, Obama, democratic, politics, reform, own, win, president, leader, etc. Technology, science, party, Jesus, team, where, machine, computer, news, feature, future, etc. And then female, personal life, happy, woman, home, house, health, honest, kind, best, book, movie. So these are the mostly predominant words in the female category. Card, beautiful, blue, pink, yellow, color, love, beauty, thank, nature. These are the words mostly used by the female users. And the common words are work, office, read, enjoy, good, cheer, great, rain, clouds, cinemas. These are the common words which are used by both male and the female users. So these are the distribution of different words used by the male and the female users. So you can see future word is mostly used by the male. Science is used by both male and female both. Work is used by mostly female. Where is basically mostly used by male. Team what is mostly used by the male. So like president, like win is mostly used by the male users. Trump is mostly used by the male users. News is mostly used by the male users. So this way, these are the distributions of different words. Lab is mostly used by the female users. So these are the basically different. Good is mostly used by the male users. So these are the different distribution of words that we have, based on our data set, we have composed of different words used by male and female. Now the third task is basically called the authorship identification. So you have to predict who is the author of a particular document. So given the documents of a set of authors, find the author of the suspect document. So a set of authors and their corresponding documents are given. Now there is an unknown document. You have to predict the author of that unknown document. So this is the model. So you have the documents written by individual authors. For example, there are 3 authors. You have digital documents written by the individual authors, and based on that, you can develop a model. Now, when there is an unknown document, you have to predict who is the author of this document. That is called the authorship identification. So there are several available data sets. CC 8010 collection of 19th century novels of British and American authors. Here, number of authors is 10. Number of texts per author is 50. A total of 500 texts in training data as well as in testing data. Then CC 8050 collection of 19th century novels by British and American authors. Number of authors is 50. Number of texts per author is 50. A total of 2,500 texts in training data as well as in testing data. Block authorship identification. post of 19,320 bloggers, a total of 6,80,000 to 288 posts. Average number of posts per user is 35 and 100 blogs for 1,373 users. So these are some other data sets like IMDb 62. This is the collection of movie reviews. Number of users is 62. Number of reviews per user is 1,000. So these are all shorter reviews. So number of reviews in a review, number of words in a review is only 349. Then there is the Enron dataset, collection of mail data of employees of Enron organization. Number of users is only 150. Then there is a Twitter-based dataset as well. Tweets posted by 7,000 users. 15% of all public tweets created from May 2009 to March 2010. 1,000 tweets per user. So we did a thorough literature survey, and after literature survey, we find out that mostly people are using CNN, the convolutional neural network, for the task, but CNN does not capture the spatial information. So you know that CNN is very much important nowadays, very much popular in solving different text classification problems, because CNN extracts useful features from the text. So CNN represented by weighted sum of lower layers, thus difficult to represent a complex object as it moves to upper layers. But CNN does not capture the spatial information. And this spatial information can only be captured by the capsule network. So basically in our task, we have proposed to use capsule network for solving the authorship verification problem, identification problem. So for example, here, if you use the CNN with pooling, then you will get the answer, yes, this is the face of a human. But CNN with capsule will be able to understand the spatial information as well. So it will say that no, this is not the face of a human. So we proposed the capsule network for solving this particular authorship identification problem. And we have also shown that named territory information can be used as an additional clue. So you can use an additional information, which is the named territory information, for improving the authorship identification problem. So basically, this is the use of capsules in the convolutional neural network-based architecture. So this is the structure of the capsule network, which is a CNN-based module only, but now it is having the capability of capturing the spatial information. And this capsule network is used along with different types of encodings to identify the author. So capsule-based CNN is used with different types of encodings. Like we have used the globe as embedding, BART embedding, character unigrams as embedding, character biograms as embedding. So we have used different types of embeddings in the capsule-based CNN to develop the authorship identification module. Then there is also a baseline which is called capsule-based KNN, where also we have used the 4 types of embeddings: globe, BART, character unigrams, and character biograms, and we developed a capsule-based model. So these are the results. So our results show that this capsule-based network is giving us around 86.52% accuracy on the 1,000 tweets per user. So these are the accuracy values. We have varied the number of tweets per user, and with 1,000 number of tweets, we are getting the maximum accuracy of 86%. So these are the different previous work. So CNN2 character biograms are fed to a CNN architecture for the classification task. CNN1, in this system, the character unigrams are fed to a CNN architecture. LSTMW, in this system, we have fed the word sequences to LSTM as input. Then CNNW, word sequences are fed to CNN as input. So there are several existing models. We have compared with all of them. And as we have seen, our model is giving 86.52%, which is an improvement of around more than 3% compared to the existing state of the art. So these are some results. So you can see that these are the keywords used by the how the attention basically helps. So it is putting the emphasis on the correct words. We also did an experiment how identity information, like whether a particular user is using what kind of entities. So if particular users style can be determined based on the entities which he or she is using. So in a particular document, if a particular entity type is more frequent, then that could be used as a style information of the particular author. So basically, we did experimentation with the type of the entities of the most in the entities which are used as an additional feature. So first develop a NAR system, then uses in the identification module. So you know, name entity recognition is a very important task. I have already mentioned. This is a step of information extraction. So here, the task is to identify and classify the entities present in a particular sentence or a document. To categorize the words into predefined classes such as person names, organization names, locations names, medical codes, time expressions, quantities, monetary values, percentage, etc. Like the Apple is the organization names, Flint Center is the organization names, Cupertino is a location name, Tim Cook is a person name. So this way we have to identify the entities. We have to first identify the entities and then we have to classify the entities into different categories. So name entity recognition of social media post having both text and the images. This is very important that from the social media post, can we predict the named entities? Where both images like Rocky is ready for snow season. So Rocky is the name of a particular person, name of a particular dog. So it can be easily understood by seeing this figure. So this is called the multimodal named entity recognition. So we are not only using the text information, but also we are using the images associated with the text for predicting the named entity information. So there are several data sets available. We also did a thorough literature survey on the data sets and the methodologies. And this is the data set that we have used. So 8,257 multimodal tweets. So there are 4,000 tweets in the training, 1,000 in the development, and 3,257. So these are the different tweets available, posted by 2,116 users. And this is the total distribution over the training, development, and testing set. These are the examples. You can see that in almost all cases, images are also associated with the text. So we use several different features. Okay. So in order to handle the image information, we apply some image captioning models. So image captioning models are basically giving us a description of an image. So those are called the captions. So those captions are used as an additional text information in this particular work. So we have a particular text, and now we are getting the image captions that is basically added as additional text information in that particular text. So there are several features that we have used, like handcrafted features. If the word is the starting of a tweet, because that is an indication that it could be an entity named entity. If the word contains capital letters, then that is an indication that it will be an entity. If the word is at the end of a tweet, maybe most likely then it is not an entity. If the first character of the word is in the capital letter, then maybe it will be a name, person name of the entity. If the word contains a special character, if the word is in capitals, if the word contains digit, if the word contains link or mention, if the word ends with apostrophe s, if the word is in lower characters, so all these features we have manually designed, and then those feature values are basically extracted for individual words. And then URL information we have used, because in many cases after the tweet there is a URL. So we have went to the URL and we have extracted we have basically summarized the information present in the URL link, and that is basically added as an additional context. So this is our architecture. So basically we are having some word embedding, word level features. There are some character level features, and we are having some handcrafted features. So given the input sentence, we have some word level features, some character level features, and some handcrafted features. This is a two-stage model. First is the feature extraction, and second is the classification. So feature extraction, word level features, character level features, and the handcrafted features are passed through by LSTM. And then CRF tagging, because it is a sequence labeling task. As I mentioned, that named entity recognition is a sequence labeling task. So in the final layer, CRF is used for the classification. So the learned representation is passed through CRF for tagging. So we develop different models varying the features. Like in the model 1, we have the word-based features, character-based features, and the handcrafted feature. Then in the model 2, we have word-based feature, character-based feature, image feature using cell attention. Then in the model 3, we have word-based feature, character-based features, and URL features using self-attention. Then in model 4, we have word-based features, character-based features, caption features using self-attention. Model 2A, concatenation of self-attention of word features, character features. Model 2B, concatenation of self-attention of word features, self-attention of character features. So this way we have basically developed different models by varying the set of features. And then these are the results. Basically, these results show that yes, our model is giving around 72% F1 score compared to the several. So this model 1 is giving us the best result, which is giving us a 72% F1 score compared to the previous all the other models. We also compared with the several existing approaches. These are the BioLSTM plus CRF, CNN, BioLSTM, CRF. These are the existing approaches. So all these approaches are giving around 70% accuracy, and we are getting 72% F1 score. So these are the examples. Error analysis. So mislabeled tags in the dataset. Basically, some tags are basically there are some mislabeled tags in the dataset that is creating some errors. Ambiguous entities present in the dataset, like whether a particular this is a location name or organization name. There are many ambiguous entities present in the dataset. So these are the most, and then misinterpretation due to handcrafted features. So like writing name identity without capital initials, inserting digits for shortening of words. So these are basically errors created because of the handcrafted features, because we assume that all the entities will start from with the capital letters, but there are some entities which are not starting with the capital letters. Then we assume that entities will not have any digit in between, but there are some entities which are a short form, and there are entities in between. So because of these handcrafted features also, those are creating some errors. So just quickly, I will discuss. So we also developed a co-reference resolution module. So I already mentioned co-reference resolution is basically determining all referring expressions that point to the same real-world entity. Like Narendra Modi is the Prime Minister of India. His cabinet wants the power on few hands only. Here Narendra Modi, he is. This is a co-reference chain. So a grouping of referring expressions with the same referent is called a co-reference chain on a cluster. So, but existing co-reference resolution systems are very heavy. They are mostly end-to-end systems. So you just give a document as a set of sentences as input, and it will basically give you the co-reference chain as the output. So the existing systems are very heavy, and those cannot be deployed on a mobile devices. But on the edge devices, basically, if you want to interact with the users, you want some lightweight co-reference resolution modules. So basically, in this particular task, we have developed some lightweight co-reference resolution modules, which are responsive, lightweight, and the energy efficient. So need of lightweight co-reference resolution. So in the previous work, we have different rule-based systems. Then different hand engineered features with the ML approaches, end-to-end models with the ELMO or the BART. So these are the existing co-reference resolution systems. So there are many rule-based systems available. There are many machine learning-based systems available. And there are some end-to-end co-reference resolution systems are also available. But they are very heavy modules, and it is not possible to load them on the edge devices. So we proposed a distilled BART based co-reference solution. So distilled BART is a lightweight BART. So we have used the distilled BART based co-reference solution system. So we convert the term token into word piece tokens, collect outputs of the distilled BART. We map the embeddings from word token into turn tokens, because turn is the we have to basically process word by word. And then final formation of the final word context representation. Then this is the overview of the C2F model. Word and character embeddings are generated by a distilled BART and globe. Embeddings are fed to the bidirectional LSTM. The encoded features are passed to form the span head and the span representation. The mentioned scores and ancillary scores are calculated using the span representations. And the softmax predict whether two spans are belong to the same referring entity or not. And at last, hierarchical clustering is used to form the coreference chain. So these are the data sets like Cornell 2012 data set we have used. So there are three languages: English, Arabic, and Chinese. And this is the data. This is the thing we have developed D-Corep small and D-Corep large. And our results are basically, you can see we are getting 70.41 average F1 score. But the advantage is that this is much faster compared to the original end-to-end coreference resolution model. So if you see the convergence curves, our system converges much faster, 60% quickly compared to the C2F model. So C2F model is the end-to-end coreference resolution model. So compared to the C2F model, this 16-bar-based model basically converges 60% faster. And we also, it is also lightweight. There is only 66 millimeter parameters, where the original system is having 465 million parameters. Okay, so I think I should stop now. And now, basically, Chanchal will show you let me show you some publications out of these works for your further studies. So if you want to like we worked on basically name entity recognition for a long time, so you can read our papers. We have papers published in ACM Talib, like weighted vote based classifier ensemble for name entity recognition and genetic algorithm based approach. So you can read this paper to understand how a name entity recognition can be problem can be solved for Indian context. So for Hindi and Bengali, how can we develop the name entity recognition modules? So this paper talks about that. Then the work that I have just now mentioned, though, this emoji helps a multimodal Siamese architecture for tweet user verification. So that was accepted in cognitive computation. So basically for the user verification, authorship verification, this the emoji, the Siamese network-based architecture is published in there. Then the multimodal name data recognition, that paper is published in Expert Systems with Applications. Why PM Mode is simple and efficient name data recognition system for tweets. Then these are this multimodal personality prediction system. This is another task which is published in ICON. And the lightweight coreference resolution model is basically also published in ICON 2020. So you can read these papers for your further, for your further studies. So now, so if you have any question, you can ask me. Otherwise, Chanchal will start showing the demonstrations. So Chanchal is my PhD student. So she will show you how, basically she will show some codes for the information extraction, and she will give you some assignments as well. Yeah, any question from this part? Chanchal, are you there?
Yes, ma'am. So, ma'am, am I audible?
Yeah, you are audible. So maybe you can share your screen.
Actually, I am not able to share my screen.
Now I think you can, because initially I was sharing the screen.
Yes, now I can. Yes.
Yeah. So you can listen to Chanchal now. I think Chanchal is audible. Chanchal is audible to me. And what about you? So like some participants, could you please confirm?
Yes, ma'am.
Yeah.
Audible.
Chanchal, you
Yes,
can start.
okay. Yes, ma'am. Okay, so yes, so a warm good evening to all of all of the students and madam. So since madam has talked on information extraction, so I will be showing the demo code for information extraction application like keyword finding from texts and named entity recognition. So mainly I will be discussing on these two topics. So I hope you all are comfortable in Python, because I will be showing the demo which uses the Python language. So I guess all of the students are comfortable in Python. So if it is okay, then I will start the demo. Yes,
Yes.
so okay, so first I
Yes.
will take the keyword extraction part. So here our task is to extract keywords from a text document. So so basically, first I would like to discuss what is the process of keyword extraction. So mainly we have the target to extract some keywords which are relevant for that text. So this is the task of keyword extraction. So mainly what we can do, so there is a method called as TF-IDF. So TF-IDF just TF-IDF is mainly used for extracting keywords. So where TF means the number of or frequency of a word in that document, and IDF is like in how many documents that word is present. Like let's say there are 100 documents, and in all the 100 documents it is present, it. So then we can say that this it is not important for one document. And if I can say that there are 100 documents, and in one document Narendra Modi is present, in 10 of the documents India is present, then we can say that okay, Narendra Modi, India, these are some of the words which are relevant to that particular document only. So in this way, we use TF-IDF based mechanism for information extraction. So firstly, the formula for IDF, we have some log based formula. So mainly what we can do, we can just sort our keywords in increasing or decreasing order of TF-IDF, and then we can just select the top 10 or top 20 keywords, whatever we want. So okay, let me show you the codes. Okay, so I hope the screen is visible. And yes, so firstly we will just import the packages, because as we know that in deep learning and NLP, now we are blessed with already inbuilt packages in Python. We just have to import them and we can use them. Now we don't need to just code all of the things from scratch. So for this, I will be importing count vectorizer and TF-IDF transformer. So mainly we need two things. Firstly, count vectorizer, which will count the frequency of each word present in the data set. And secondly, there is one TF-IDF transformer which just transforms the whole vocabulary using the data set into TF-IDF vector form. And whatever will be the value of that vector, that can be called as the weight of that word. So for this, we will be importing count vectorizer and TF-IDF transformer. So then we will be reading the dataset file. So this is the dataset file Stack Overflow Data IDF. So this is well-known dataset for keyword extraction. So and after that we can do the pre-processing. As we know that the data or the text document which we have is not ready for the NLP based task, so we have to do, sometimes we have to do the normalization kind of thing. And for those normalization, these regular expressions and stop words, punctuation marks, and lower casing of the text document are mainly used. So mainly we for this task, we will be first converting the document into lowercase. Then we will be removing tags which will contain special character and digits. So in this way we can pre-process our text. And then mainly we need only the body of the text and the title. We don't need anything else. So we are just using this as our data frame. And so this is one example. So this is the text document. How do I prevent floated right content from overlapping main content? I have the following HTML. So okay, this is what is present in the sample. So we just have to extract important keyword from this text. Okay, so then we will be removing the stop words, because stop words are not useful in keyword extraction, because no stop word can be the keyword. They are the general things which is used in English grammar while writing. So we will be removing stop words. And then we can use the count vectorizer count vectorizer for counting the words present in the document. And for this, first we will we will call this count vectorizer using max df is equal to 0.85%. So 0.85 means we will be ignoring those words which are appearing in more than or equal to 85% of the documents, because they won't be that much relevant for relevant, which can be called as keyword. So then we will be removing stop words also. And finally, this count vectorizer cv dot fit transform. So this fit underscore transform does the counting of words of a document. So this cv.fit transform make a word count vector which will contain the frequency of each word occurring in each of the document. Okay, so now we can also restrict the number of words up to some limit. Like let's say we can restrict only 100 words or 1000 or 10,000 according to our need or according to our system's need also. Because if we will have large number of vocabulary, then the system will take a lot of time for execution. So this can be changed according to our need. So okay, so this count vector is similar from the above cell. In this cell we can just use max features equal to 10,000 or 1,000, and then it will use only that much number of vocabulary. And finally, similarly, cv.fit transform, so this will make a count vector. And then we can use a tf-idf transformer on this word count vector. So this word count vector will give word count for each document, and then we can use just tf-idf transformer on this count vector. So now so up to this level we have a tf-idf transformer which is fit on a set of documents. Now we just need to test this fitted model. So what we can do, we can just feed the similar kind of test data can be feed, and pre-processing and everything will be done according to the training data. And then we have defined two function. First is sort co-occurrence matrix, and the other is extract top n words. So in this sort co-occurrence matrix, what was I telling, that we can just sort it according to the weights of the words, and then using those weights we can sort it, and whatever will become upward or downward, that will be our top n words. Mostly the sorting is done in ascending order. So yes, so last of the terms will be our top relevant words. And similarly, extract top n from vector. Yes, this does the same, the extraction of the things. And now what we can do is we can define get keywords function, which will use so in this function define get keywords idx, you can see that okay, we can feed one index of a test data. Okay, let's say that we want to extract the keywords of index number 120. So we will just feed 120 index. Then in this function we will use this tf-idf transformer, which is already fitted on on the count vector of that document. Yes, so in this way, first count vector will be created tested on this doc test IDX, like document number 120. Then using this count vector, TF IDF transformer is transformed, and then we can just sort these things, and finally we can extract our top 10 or top 50. Like here we can set the number of items, 10, 20, whatever we can set. So in this way the keywords can be returned and finally results. So let's say I will put 120 as IDX, and let's me change it to 119. Okay. So yes, so for 119, this is the title. Errors occur during the build, and bodies IMGGTS to run my Grails project whenever I save my building workshop. Okay, so this is the complete body, and here are the keywords. So this is the keyword, and it can be seen that errors, builder, occurred, SLF, build. So these are some relevant keywords and the weights are also shown. So in this way we can extract keyword for a sentence or a sample of a document. Similarly, if we have to extract the keyword of whole document, then we can just pass each and every sample to this function, and then yes, this function will generate the keywords accordingly. So in this way we can extract keywords. So yes, so does anybody have any issues in this keyword extraction code?
No, ma'am.
Okay. Okay. Yeah. So yes, so actually I have given an assignment using this keyword demo. So you need to understand at least this very much clearly, because the assignment will be based on this. So if any issues, then surely you can ask. Okay, now let me demonstrate the other code. So yes, the other code is based on recognition of named entities. Like our target will be to tag a paragraph with the named entities. So we will be using the IOB format, beginning, intermediate, and others. So yes, so for named entities, firstly, there are many inbuilt models which we can just import and use as our named entity tagger. So the first one which can be used from the NLTK. So NLTK is a very important package of Python which does almost all our requirements related to text pre-processing. So whatever we need for text pre-processing, almost everything is in NLTK. So if you all are not aware about this, so if you need to do anything in NLP, so first explore NLTK based thing. So it will do half of your thing regarding text pre-processing, and there are so many inbuilt classifiers and inbuilt pause taggers, named entity taggers, co-reference resolution based thing. So many of the things are inbuilt in this NLTK package. So most of the time you just need to import this NLTK, and your half of the pre-processing and other things can be done. So I am using this NLTK based named entity tagger first for showing the demo. So yes, so I have taken a paragraph. This European authorities fined Google a record of $5.1 billion on Wednesday for abusing its power in the mobile phone market, and ordered the company to alter its practices. So our main task is to tag this sentence with the named entities present in it. So okay, so first I will be importing this NLTK package, and I will be importing all the libraries related to named entities like word tokenize, pause tag, and any chunk. So pause tag just tags the sentence as per its part of its speech. So like European authorities, so maybe it will be paused as NT, find VP, Google NN. So in this way it will pause tag. So part of a speech will be tagged. And then there are some inbuilt text files like punctuation, any chunker, words, average perceptron tagger. So these are some already developed model and files there, and we just have to download it for using. So like this is the sentence. And yes, so for pre-processing we just need to import this word underscore tokenize for tokenizing a sentence. So by tokenizing a sentence, I mean that it will split all the sentence in word by word, like European, then other word will be authorities, other word will be find. So in this way, and then when we will have our tokenized sentence, we can just call pause tag for pause tagging it. So in this way, it will, the output will be like European, JJ, authorities, NNS, find, VVD, Google, NNP, a determiner, record, noun, dollar dollar, Wednesday, NNP. So in this way the whole sentence will be pause tag. Okay, so now um, for using NLTK based named entity tagger, we have to use the parsing kind of thing. So we have, first we have to parse, and then using parser we can identify nouns, because name nouns will be the named entities. So let's say this is the pattern, like this pattern is defined by me only just for the demo purpose. So we can define different patterns according to our need. So let's say a noun phrase should be formed if an optional identifier followed by any number of objectives and a noun is present. So it means whenever we have either determiner or not, and then maybe one adjective or no adjective, or many number of adjectives, and then finally noun, then this we um, then this we can call as noun phrase. So I hope, am I still audible?
Yes.
Yes, okay. Actually, I thought there is some network issue. Yeah, so in this way, the noun phrase can be identified, and then we can use this regular expression based parser using this pattern. Like on this pattern, we can use regular expression based parser for parsing the sentence. Then now in this way, the sentence can be sentence, then this European, authorities, find, Google, dollar. Like in this way, the sentence tree can be developed. So actually in Google Colab, I was not able to show the parse tree. So in this way, we can develop the parse tree using sentence. So yes, so now NLTK has two different libraries: kernel tags to tree, comma tree to kernel tags. Kernel tags means if when a sentence is tagged in the IOB format, which was introduced by the kernel dataset, then it can be called as kernel tagged sentence. So yes, so we can NLTK in NLTK provides us two different libraries. Kernel tags to tree means from the kernel tags we can draw a parse tree, or from a parse tree we can draw a sentence which will be tagged by the named entities. So we have already developed our parse tree. So for this, using tree to kernel tags, we have developed this parse tree. And now we will be using tree to kernel tags on our past tree CS. And then yes, so CS, and this will give a IOB tagged sentence. So yes, this is the printed IOB tagged sentence. So now European, so this is the pause tag JJ, and O other, authorities, NNS other, find, VVD other, Google, NNP other. So in this way we can see that most of the things are not correct. Like Google cannot be called, cannot be put in the other section, but yes, record is INP, power BNP. So in this way we can say that this named entity tagger proposed by NLTK is not so much powerful. Like yes, so let me see using this any chunk. So any chunk, as ma'am has already defined, that chunk can be called as the grouping of words for a particular like if we have to draw a parse tree, then we will group the word as per the parse tree or parsing rules. So in this way any chunk is used. So any chunk is used on this pause tag and word tagonized, and then this will form as GPE. So European will be GPE, like this is uh, global sorry, I don't, GP is actually for city, states, rivers, like name of these things GP used. And then Google is tagged as person. And then yeah, so these are the 2 or 3 things which have been identified from this any chunk based tagger. So in this way, like till now I have shown you 2 type of tagger. First one was used NLTK and the second one has used any chunk. So but still we can say that these the 2 taggers are not so powerful. So then we can switch to the third type of tagger, which is served by Spacey. Spacey is also a package of Python, which gives us, which also stores different kind of models. We just have to load the model, and then the model will do everything by itself. So like we have to just import this en underscore core underscore web underscore sm. So this is for entity tagging, and we just have to load this. And in this object NLP, we just fed all the fed our sentence, and then this has printed the tagged entity. Like this NLP passing our sentence to the NLP object, a document or a pause tag document is found where we can say that yes, the all the named entities are tagged. So mostly are correct, like European is tagged and NORP, Google organization, billion, money. Okay, so these are our money. So yes, Wednesday date. So in this way this is tagged, so it is better than at least above things. So and yes, we have one display c dot render object from which we can display this thing beautifully. Like here it is in normal tokenized form, but now it is in like all the entities are highlighted in different colors, like European, NORP, Google or organization, money, date. So now let's say, so till so here from till now we have tagged one sentence. So now let's say we have to tag a complete document. So for tagging a complete document, maybe we can use normal document, and we can just load it and feed it to NLP. Let's say we have one URL, and we have to fetch the text from that URL, and then tag all the sentence, all the named entities present in that URL text. So for this, we can use this URL to string function, which uses beautiful swap or and requests. So if this request is used for downloading the things from your from for the given URL. So yes, so this function just downloads the things that is present in that website and convert it into a normal text. So this I have put just, maybe some of you would be interested in data scrapping, then this function will help. So this is why it is put here. So this function can just convert the data which is present in on some website into a text format, and then we can just use this text format and ny underscore bb to the NLP object which was developed, which was defined. Yes, one second. Yes, so here we have defined this NLP object, and yes, in this NLP object only we have to feed the document, and this document will be tagged. So in this way, the whole document is tagged. So it's a very big document, so it is very tough to read here. So this is why I have displayed it. So okay, so we can see here. Yeah, so in this way the whole document is tagged, like FBI agent who criticized Trump in text is fired. So FBI is organization, Peter Strzok person, text organization. Okay, so this is I guess wrong. The New York Times wrong. Organization, Peter Strzok or person. Okay, so everybody, every time text is organization,
Okay, trump in text, actually it is followed by in, so that's why the named entity tagger is behaving incorrectly. So this is what for what we have to do some error analysis, that why our model is doing errors. So this is, so from this example only you can have the sense of a little bit error analysis, that okay, model has done error, that text is organization, but it's why, due to, because trump in texts, so mostly noun phrase followed by preposition where in is the proposition, so mostly we can expect an organization to come. So that's why, because this uses sequence labeling classifier, so it uses the whole sequence for labeling. So this is why sometimes named entity, powerful named entity tagger also does some error. So in this way the whole document can be tagged. So yes, so in this is the presentation regarding keyword extraction and named entity recognition. So are there any questions? Okay, so can same thing be possible for Marathi language using NLTK? So actually NLTK supports different languages, so I am not sure whether it supports Marathi or not. So you just have to check it out, because it supports a number of languages. So yes, we have to check it out. Any other questions? Am I audible?
Yes.
Yes, okay.
Actually, your explanation was too good for the basic.
Thank you. Actually, yes, actually I'm looking for some more questions or any queries.
You have explained everything in a simple manner. Thank you, sir.
Okay. Okay, so maybe if we have time, then I can show some more demo related to the applications of IE, where ma'am has shown my work. So if we have time, then I can show a little bit, not it's a very little, yeah. Okay, so this the authorship identification task. So what was the identification task, where we have to identify who is the author of a text document or author of a tweets or anything else. So I have not put the training part here, because training part is very big and most probably it won't fit on collab. So just for the general understanding, how can we show a demo? We can train our NLP based model, and we can save the weights, and using those weights we can use our model for testing anytime. If the weights are very small, then we can run it in our personal system on, or if they are a little bit large, then we can use Google Colab or Kaggle, and if they are big, then of course we have to use powerful systems. So in this system, where I will be showing the authorship prediction, so where I will be just using my save weights. Yes, my saved weights and the embedding matrix which was generated. So mainly if we are dealing with text pre-processing kind of thing, so either we have to use normal 1001 based encoding, where we don't have any embedding matrix. Otherwise we generate one embedding matrix regarding text of that text, which saves the embedding vectors for the words of the training data. So mainly we have to save the weights and the embedding matrix in such form, such that it can be utilized on the test data. So I have just loaded the embedding matrix and the weight files, and then just in the data encoding is put, and now we don't have to do anything. We just have to load our model, and then in the loaded model we have to put the test data, or we have to just feed the test data for prediction, and it just predicts the output. So in this way we can show the demo of any NLP based model which is already trained. So in this way, yes, the demo can be shown. So I thought maybe I can discuss about this. So okay, so I guess I'm done regarding this demo. So any of the questions are welcome. Okay, so if nobody has any question, then I guess ma'am will sending you the assignment, and the assignment deadline will be tomorrow 3 p.m. So everybody has to submit that assignment. So it's not very tough, and I already have put the keyword demo based code. So you just have to make you just have to extract the keywords for long document, for the complete document, and here I have shown the keyword for only one sample. So this is the assignment which you all have to do.
Hello, ma'am.
Hello.
Ma'am, can you show the next code of after this def create vocab set function?
Okay. So if you okay, yes. Actually, in the encode data function, I have just I am using unigrams for feeding into the model. So I am just converting the test data into unigrams. So this is what
To create embedding vector matrix, no?
Yes. So actually here is no embedding. So I am just creating the character, splitting character by character, so that it can be fed to the CNN based architecture.
Okay, ma'am.
Yes. Yes. So this is the thing. So that's what I was telling, that we just have to manipulate our input data in the format what our trained model needs, and the manipulated input data just need to feed out to the model. So yes, this is what I have done.
Yes, ma'am. Thank you.
Okay, so regarding the code uploading, I will share the code with the TA, and then I guess he will be uploading to the classroom because I don't know how to upload in the classroom.
Okay, thank you.
Yeah. Okay, so now what needs to be done? Like, am I supposed to leave, or there is some other session?
Yeah, hi Chanchal. Since your the content is already completed, so I think
Yes.
so they have to take. There's a take-home assignment, right?
Okay, okay, sir.
Uh, yeah. So I think then if there are no questions, then I think then we can finish. I mean, close the session for today.
Yes, sir. So I guess the Janisa has already uploaded the assignment on classroom.
Yeah.
Chanchal happen done. Chanchal.
Yes, ma'am.
So now what to do? They will be doing the assignment.
Yes, ma'am. But the assignment deadline is tomorrow.
Okay, so they will submit the assignment by tomorrow.
Yes.
Okay, so somebody was asking for the slides, so I think I will submit. Janisa, are you there?
Yes, ma'am. You can share your slides with me so that I can share with all the participants.
Okay, I have your email address, na?
Yes, yes.
Okay, surely I will be sending. Okay, then any other? Any other question?
Yes. So for any doubt regarding assignment, I have written my email ID chanchalitp@gmail.com. So you can just mail me regarding any doubt for the assignment.
Thank you, ma'am.
Chanchal, do you want to
Okay.
show something? So, Chanchal?
No, ma'am. Like I have already shown and everything is done. So I guess sir has already told that if we are done, then we can just end the class.
Who is there?
I don't know.
Hello, ma'am. I'm Surupendra. I'm working under Prasenjit, sir.
Sure.
Yeah.
So we can log up now. We can log up.
Yes, ma'am. We can close the session. If there are no more questions, then we can close the session. And then, yeah. Then if they have any doubts, then they can mail to Chanchal or
Sure.
and submit the assignments by tomorrow.
Sure. Then, so good. Very. Yeah. Hope you have enjoyed the session, and you please do the assignment. And if you have any doubt, you just mail to Chanchal. Okay. I hope, and I will be sending you the slides.
Okay, so thank you everybody for listening the demo session and the presentations.
Okay, then.
Thank you.
Logging up. Yeah.
Yep.
Okay. Bye.
Okay. Thank you, ma'am.
Bye.
Thank you. Bye. So we see tomorrow again at to session starts tomorrow again at 3 p.m. Thank you.